1, 2, 3, 1, 2, 3. 1, 2, 3, 1. JSConf. Hola, 1, 2, 3.
One. Three, two, one. 3, 2, 1.
Bienvenidos and welcome. I'm going to talk a little bit about the conference. La conferencia más que nada va a ser en inglés. Vamos a tener obviamente traducción simultánea, está disponible al final. But since it's an international event that's being streamed live to tens of thousands of people right now, I thought I was going to introduce the conference, which we did first in 2012, 2 years ago in the Centro Metropolitano de Diseño. We had like 230 people. It was a really amazing party, and now we've decided to triple it. And that wouldn't be possible without our sponsors, which you've seen throughout the day. Hopefully you get to connect with them, you get to talk to them during the day. A lot of them have come from far away. My team at WordPress, we have people from Google, I know Auth0. There's a lot of gifts that you're gonna get from them and a lot of valuable lessons. The conference primarily is about you. I want to introduce our team first. My name is Guillermo Rauch. I'm going to introduce later your host. Everyone that has a yellow t-shirt you can get to for help. The most important thing is that we keep respectful with everyone to maximize the happiness of the conference and the event. There's a code of conduct that we've posted online, and there's a short version of it that's on your cards alongside the schedule. Keep your badges on. That's the only really requirement other than the great conduct. As far as the spaces, we have made a special cafe on the back, sponsored by DigitalOcean. We'll have food throughout the entire day. Feel free to use the breaks to connect with others. Feel free to talk, get a snack. If you're tired, if you need a break, also don't hesitate to take your own time and use the spaces. I want to spend a little bit of time talking about the themes for today. The first one is learning, and it's really important to me that Jennifer is here today to teach us how to learn. There's a lot of content that we're going to learn about today. A lot of content, a lot of different things you can do with JavaScript, and I think it's impossible for us to all memorize or even know about these things before today. So I think it's important that we learn how to learn and how to basically make progress with everything that's presented about today so that it's meaningful and it helps you with your work and your lives. The next major thing is we're going to talk about how to implement the JavaScript that is already here today, but to a lot of us, it feels like the future, ECMAScript 6, and how we can really start utilizing those functionalities today. And we have two amazing talks by Jaydson and Sebastian. Equally important, I think, is the idea of not just focusing on the code, but also focusing on how we visualize data. So we have Mr. Doob talking about 3D, we have talks about parallax by Evangelina, and we also have talks about accessibility and internationalization. Beyond the web, we have a lot of talks today about hardware, we have talks about artificial intelligence. A very interesting thing that's happening today, and a major part of the theme of our conference, is everything that's beyond the web. We're very excited about mobile, we're very excited about artificial intelligence, we're very excited about hardware, and we have really amazing speakers and demos and presentations about that today. Reusability, we'll learn about how can we leverage existing code, how can we take components that already exist and reutilize them. And I think that's one of the important things that builds up the community. I put up some code online, and you guys can share it, you guys can utilize it, you guys can improve it. And scalability is equally important. What happens when we grow? What happens when we're using JavaScript on the server? Alvaró and Tomasz are going to teach us all the lessons they've learned about delivering messages to like hundreds of thousands of connected users. I think it's going to be really exciting. And finally, we're going to talk about the future. When I was reading Andreas's presentation title, I got really excited because he's running Java within JavaScript, which finally puts an end to the whole distinction problem. Because when people ask me, what do you write? I tell them JavaScript. Oh, Java. Okay, I got it. So today with Andreas, we can say, yeah, we can also run Java inside JavaScript. And finally, we're going to have a talk with Brendan and Andreas at the end, which is why we have this space right here. We're going to get to, all of us are going to have the ability to submit questions to ask Andreas and Brendan. How do we submit those questions? Throughout the entire day, please don't hesitate to tweet, talk about the conference. We have a hashtag, we have a swarm location. You can Instagram and find JSConf Argentina. For all of us that couldn't make it, all of us that couldn't buy tickets, we have our online stream sponsored by Google. It's on YouTube, and this link will embed it right away. Don't hesitate to share that with your friends as well. And last but not least, I want to introduce your host for the day, Gonto.
everyone. How are you guys? Are you all ready for JSConf? So let's try this again. I'm going to say, are you guys ready for JSConf? And you all have to scream, yes. So, are you guys ready for JSConf? Yes. Awesome. That sounded awesome. So, as Guillermo was saying, now we're going to start with JSConf. So, this is streaming live, so no pressure to the speakers. There will be thousands of people watching it live right now, so no pressure at all. I have to say, hi, ma'am, I'm on TV. When I was told that I was going to be the host, I was really excited because I thought in the Oscars, Barney from How I Met Your Mother is going to be the host. So I was like, oh my God, I'm going to be like Barney, and I love Barney. So this is going to be legend. Wait for it, Dari. So right now, we're going to start with our first speaker. She's going to be setting everything up. And as Guillermo was saying, the idea is that we're going to start with education. And I think that it's really great that somebody could learn in 180 days, and only in 180 days, how to code. For me, it was like a lot of time. I started coding when I was 12. It was a lot of work. I had to learn to code. And I was like, what is this? I didn't understand everything. But it's amazing that in only 180 days, she was able to learn to code. And actually, that's what she's going to be speaking about in a few minutes. So let me first introduce you to our first speaker. She's Jennifer de Walt. I feel like she's the new Phileas Fogg from Jules Verne's. Phileas Fogg did in 80 days, she did the whole world tour in 80 days. And for her, it was in 180 days, the whole coding experience. She just learned it. And the idea is that in 180 days, she did one website per day. One website per day. For me, doing a website is always a lot of months. And she did one. I want you guys to give a very, very, very loud round of applause to our first speaker, which is her.
So I'm a software developer, but I took a rather unusual path to learning to code. I taught myself how to code by making 180 websites in 180 days. So I grew up on the east coast of the United States in a suburb of Philadelphia, where my family has lived for over 250 years as farmers and small business owners. And while there was a lot of do-it-yourself spirit in my community, there wasn't a lot in the way of art and technology. And growing up, I didn't have any role models for what a software engineer even was. So when I went to college, I ended up studying fine art, in part because it had absolutely nothing to do with farming, but also because I was really passionate about making things. So while I was there, I ended up going to an art museum with a friend, and we were wandering the halls. We got down to the basement, we turned around a corner, and we were confronted with this. Why is it not coming up on the screen, guys? Let's try that again. Any thoughts, guys? Am I getting some technical help, perhaps? Okay. Okay. It's always rough being the lead-off speaker. You have to guinea pig all of the technical problems. we still have a little bit of a resolution problem, but maybe I can keep going and hopefully somebody can get that fixed up upstairs by pretty soon. So as I was saying, I went to art school, and I was in a museum, and I came across this sculpture, which is a little hard to see, but this is an amazing sculpture. It's Ron Muick's Big Man, and this sculpture is incredible. It's a 7-foot-tall, hyper-realistic sculpture of a very large dude, and it's absolutely breathtaking. As soon as my friend and I stepped into the space, we immediately dropped our voices down to a whisper. It was that powerful. And I remember thinking to myself how unfathomable it was that this thing even existed. I mean, the sheer size of this thing, the weight, the cost, and especially the amount of skill an artist would need to build something so complicated and so detailed and so beautiful. It was an experience I took with me all the way through grad school. So after grad school, I felt like there was this explosion of technology happening all around me. We have all these amazing products that are getting made, from open source projects like Docker. We have new communication platforms like Twitter, wearables, Internet of Things, all these amazing things. And I realized I wasn't satisfied with just using these products and just start there and then eventually jump onto something bigger. And this was appealing in a lot of ways because, I didn't know what I was doing, so this would allow me to get comfortable with tools for building websites and also how websites were even built. But then I was left with the nagging question of how many of these websites would I need to make before I moved on to something bigger? And would I ever actually feel like moving on to something bigger? So I said, okay, what if I just jump right in, tackle one big app? And this is appealing to me in a lot of ways because it would get me right to what I was ultimately interested in doing. And a lot of people have gone down that path themselves and been very successful. But as a beginner, this seemed like a really large mountain of knowledge to try to climb. So that left me with the third crazy option, which was build 180 websites in 180 days. And it turned out this was great. For me, it was an intense, immersive learning environment that allowed me to explore any and all ideas that I found interesting along the way, and gave me plenty of room for productive failure. So I set out 3 rules for myself. First, I would build one website, one website a day, excuse me, one website a day, every single day for 180 days. Each website would be accompanied by a blog post. And 3, all of the code that I wrote would be publicly published on GitHub. And so throughout the project, I was able to do a whole bunch of different things. I was able to learn HTML, CSS, JavaScript, Ruby on Rails, even a little bit of Node.js. I was able to make toys, games, tools, data visualizations, even real-time communication apps. And by the end, I was able to build the dynamic, interactive web apps I'd originally set out to do. So on April 1st, 2013, I made the very first website for the project, and that's the homepage. Now this is just a couple of lines of HTML and CSS, and it took me all freaking day to do. So it's not much, but it was a start. And so by day 3, I was ready to get into some interactive JavaScript awesomeness. This is random color coming out, and you can add more of those as well. And as the pulses move out, they pass by the notes, and they pluck them, and they flash. And so you can add all of these different things, get them all styled up. And the thing I really love about this app is that the more visual beauty you put into the system, the more audio discord goes into it. So it's a really interesting contrast between the two. Okay, real fast, close it up. So at the end of the project, I started using Node.js, which gave me access to real-time data. So here we've got a bunch of hashtags on the screen. These are listening to the Twitter streaming API, and as those hashtags come in, they flash on the screen, and they get tallied up into a positivity rating, so you can see how happy Twitter is right now. And from day 179, this is AllDraw, and it's a collaborative drawing app. And so here you can join with your friends, and you can sketch together, you can draw messages, you can mess up each other's stuff, whatever. And the thing that has always fundamentally fascinated me about the internet is its ability to connect us in a way that we can share ideas and information in basically real time. And I think AllDraw really encapsulates that feeling for me. So those are 40 of my websites, and along with the other 140 that I made is how I taught myself to code by making 180 websites in 180 days. Thank you.
So thank you, Jennifer, for everything. Apparently, now I have to talk a little bit more and slower so that we can set up the computer quickly and there's like no glitches and no anything. So I'll try to speak a little bit slower. I usually speak very fast and move a lot. So we've just learned how to code. Now we went from nothing to learning how to code. Now it's time to learn some awesome features, some awesome new features that are going to show up in JavaScript. Our next speaker is from Brazil, and he's going to talk to us about ES 7-1. Oh no, that's how Brazil lost against Germany in the World Cup. Sorry, I had to say it. I mean, he's from Brazil, we have to say it. So unfortunately, ES7 is not yet coming out, but ES6 is coming out right now. And that's exactly what he's going to be talking about. He's going to be talking about how awesome new features, how awesome new things we can do right now. Also, some other things that I can say from him is that he's a developer at Terra. Terra is one of our sponsors, so we have to thank Terra for getting him here and getting him to talk to us today right now. He's also the Brazil JS conference. So if any of you guys want to talk at the conference, if any of you guys want to talk at Brazil JS, maybe you should buy him something, give him something, I don't know. We like bribery or something like that? No, we don't. So, but maybe he can get us into the conference. He's also one of the makers of the ES6rocks.com, which is a website that pushes the information to everyone so that everyone can learn about ES6. And that's really amazing.
Just define a current language, and then I define the strings of my application. Here I'm defining the English message and the Spanish Argentinian messages. And then the implementation is pretty simple. Well, I'm offline. Okay. The difference here, I'm looped to the strings, and then I'm just pointing to the object literal with the specific language. And this is how to use it. I have some variables, and then I tag the template string, and boom, we have now the message in Spanish. So you can imagine a lot of things you can do with template string. This is a pretty simple example with I18N. Moving to for strings to numbers, we have a lot of things in numbers now in S6. One of the fun thing is we have octal and binary literals. So now you can explicitly specify if this number is octal or if it's binary. This is pretty useful. And we have these two methods, is finite and is not a number. I think is as well known, the is not a number is a well-known method in JavaScript. Actually, we already have these methods, but it is in global scope, and now they're moving to the number object. That make a lot of sense, and then they try to fix some issues. If your application using a lot of math, if you are a hardcore programmer using a lot of math, you definitely check it out, all of the new methods in math object. We have a bunch of new methods. We have also a lot of things in array objects. We have a lot of methods like our array.from that I will show you, array.of, array.find, fill, and we can also subclass in an array. But here in this example, I will show you array.from that takes an array from another thing, like an iterator. Here is the JSConf website, and then I'm just querying the DOM, looking through to the speakers, and then I can specify a second argument that is a map function, and I'm using an arrow function that we will see later, and then I'm just logging the inner HTML. we have a shorthand in objects. If you are a JavaScript programmer, you have this common situation where we have a name, the same name for the properties. So if you want to return or create another object, you need to define the property and the value, even if they are the same. So with this object literal shorthand, if you have the same name, you can just put 1. You don't need to specify the property and the value. Also, we have the structuring assignment. Here is a way to define, it's another way to define variables. Here is using the array pattern. You can just define like this. And we have also the object pattern. That looks weird, but it works. So, about the main features, we have block scope. You see I'm using let in the other examples. Block scope, the difference for let and for var. I don't know if let is a replacement for var. I think it is, but I see a lot of people saying that no, let is not a replacement for var, but I think it is. So let define a variable in just the scope. So in this example, I'm creating a for loop, and this block I'm creating this j variable. So this j variable just exists here in this block. If I try to log outside of this block, it will fail. And we have arrow functions that is well known as lambda in other languages like Python, I think C# and other languages. And it looks like a dime bag flying V, the symbol. So the arrow function is not newable. We cannot make a new arrow function. That makes a lot of sense. And we don't have the arguments object anymore in this arrow function. And this function is always anonymous. And we have the this binding fixed, and we will know how. Here's is how arrow function works in a simple way. So I'm creating this variable, it's a function, and then I define the parent name, and after the arrow, we have the return. We don't need to specify the return. So it's a pretty simple example. In this constant.log, we will output 6 because I'm passing 5, and then here x turning 5, and then after the arrow, x plus 1 will be 6. It's pretty simple. We can have more parameters. So if you have more parameters in an arrow function, we need to open and close the parentheses. And if you don't have parameters, you need to open and close the parentheses like this. And if your arrow function will need a lot of codes, you need you need a body. You need to open the curly brackets like this. The main difference here is that you need to return something. Okay. And here is the classical issue with the this. Every JavaScript programmer know this issue. That if we have a function inside a function and then try to take the this, we lost the reference for this. So in this example, we will have this type error. This the log is not a function because here these have the log methods. So we already have a way to fix this issue with ES5. And we just need to wrap the function with parentheses and turn this into another just sugar syntax. Okay? We don't have any change in the core of the language. It's just another way to do something. And how to use in class, this is a valid AS6 example, a classical example. We have the class keyword, we define the class animal, and we have the constructor, and we have the method. Here, it doesn't need to define the function keyword, we just define the method. And we can extend a class, and we can use super. So, if you want to use classes, you can use it. If you don't want, you can keep with your own style. About modules. Modules is, for me, is one of the most exciting features in ES6, but it's still changing. We have the module loader in another spec, but it's still one of the greatest features in JavaScript. So here's how to do it. I'm creating a file, bas.js, and I'm defining a variable, okay? And of name it exports and default exports in a module. And we also can import a module inside another module. So here you can see in this full.js module, I'm importing another module. And then I can export the default full, that is a single function, but I can also export a named this variable bar. And for use in my application or in another module, I can just import the named with open and close the curly brackets. Here's an example that I will show you later, how to use in modules, importing named and default exports, and just using it. And how to use it today. I'm using now the 625 project. 625 is a project that turns ES6 code into a valid ES5 code. So why I'm using 625 and not another transpiler like Tracer from Google? It's because 625 is a pretty active project on GitHub. I think the guy that wrote this library works a full day in this 625 project. And we don't need any runtime, we don't need extra library for using 625, so it's great. And the generated code is human readable. You can actually open the generated code and you can understand what has happened. And if you want to use modules with CommonJS, you can plug Browserify and you can use Grunt or another Gulp or Broccoli or whatever you want for. So here is an example that is in my GitHub, and I will try to demonstrate. So here I created this grunt file that just use 625 and use Browserify, and I can run. I don't know if you, oh no. Okay, believe in me, I'm running grunt, and I'm specifying that I want to convert my modules to CommonJS. I think is CommonJS. So I can use CommonJS so I can run with Node. So here I'm in the sample. And common app.js. And then I have my modules working with Browserify. But if I want to use this in the browser, I can just serve my folder. I can see the bar. So, okay. The thing is, I can run the modules and I can turn into CommonJS modules or AMG modules, so I can run in Node with CommonJS. I can run in the browser with CommonJS using Browserify, and I can run, I can turn into AMG, asynchronous modules definition, and I can run, if I want, asynchronous modular loading in the browser. So here's the ES6 support today, and there's no bug in this chart. Yeah, this is true. Internet Explorer is 70% of ES6 implementation. So we have Firefox with 60. So we are almost there, okay? ES6 will be officially released in mid-2015. And if you're using frameworks like these popular frameworks, they are also moving to ES6 modules and another ES6 features. And here's a project that I mentioned, ES6rocks.com is a website for spread the information about ES6. And today, we are launching a new version of ES6 Rocks. So if you will try ES6rocks.com, we have a beautiful new website. And last thing, to build this website, I created Harmonic, that is a static site generator using ES6 features. You need to check it out on GitHub and contribute. And that's it. Here is my contacts. Thanks.
Okay, so thank you, Jaydson, for the talk about ES6. I'm actually impressed by his ability to use the laser. I mean, every time I do a talk and I use the laser, I never point it correctly, but he has like a great ability. I don't know how he really does it. Anyway, we've learned about ES6, and as he was showing right now, ES6 is not yet implemented in all browsers. So our next talk has a lot to do with that. There are two ways of implementing something that is not still in the browsers. You have the option to use a library, which you can use to use these methods if they are not there, or you can use a polyfill. And this talk is about that. Our next speaker works at Facebook. He works with React, and he's part of the TC39 committee. And what he's going to be talking about is about this very, very, very controversial subject, which is polyfills versus libraries. So I have to say something more, apparently. This wasn't prepared because he's still setting up, so I don't know. I can say la-la. But anyway, say a big, big, big round of applause to Sebastian Markbage, which is our next speaker. Thank you.
Thank you. I'm sure it's fine. I'd like to start off with a question. Does anyone have a favorite utility library like Lodash or jQuery or something like that? Who uses Lodash? Underscore? Knockout? That's cool. Isn't it great that we have this community that we can use all these different features and different libraries as we want to, and nobody can tell us that we can't do it, and there's like no single company that controls our community? Except, do we really need this many ways to iterate over an array? Do you even know all the ways to filter an array in underscore? Is it the same exact version in Lodash, or is it, I think it's slightly different depending on which version you're using. Do you even know all the JavaScript standard library functions? What about the ones in ES6? I don't think Brendan even knows all the ones in ES6, pretty sure. Let alone all the libraries on top of it. It's not that a library is too big. It's pretty cool. Every library is pretty cool. It has some nice features, nice extensions. The problem is that we have a lot of them, and each one has a lot of different functions. And the total amount of APIs that you have to learn to be productive in this industry is huge. And it's way too much to learn. So what happens when you get a new team member coming onto your team? How many special utility calls do they find in your code base? And how much ramp-up time do they need to figure out what's actually going on there? So why do we actually use JavaScript to begin with? It's not the best language in the world. Regardless of what style you prefer, there's at least one language that's better that can compile to JavaScript, except JavaScript is everywhere. This is why we're using it. It's at least something that a lot of people could agree on, and our industry needs a baseline to build on top of. So JavaScript is one of those baselines that we can build on top of. And using a standard comes with a lot of benefits, like information is accessible, tooling, people to hire, and so on. So by introducing divergence in the library community, we're actually undermining what makes JavaScript great. We're already creating an environment where you can't hire a JavaScript generalist anymore. You have to hire a JavaScript specialist in a specific library. At Facebook, we have a very simple story. We use JavaScript's standard library. There's one way to do things, and it's the standard way. We don't have an underscore, we don't have utility libraries, and it avoids a very simple problem, bike shedding. It's the biggest waste of time of all. We still have to do that, but we keep that to the standards mailing list, and most of it is arbitrary anyway, so it doesn't really matter that much. So why is our industry still using so many JavaScript libraries? Well, the standard library is pretty small, and it doesn't have all the features that you may want, but many times the answer is just write a little bit more boilerplate code. It takes you a few seconds longer. You don't take on a dependency. The person coming to fix your code later after you're left, or if you're busy in a meeting, they don't have to learn some obscure functions or 20 other versions of the same functions that someone else thought was slightly better than this one. One of the best lessons that I've learned at Facebook is that no abstraction can actually be better than a wrong abstraction. And especially since abstractions build on top of each other, they're difficult to unwind. So proving that a general abstraction is worthwhile can actually be quite difficult. And teaching it to our entire industry is even more difficult. It takes time. And this is the reason why standards are slow. You may want JavaScript to copy a feature from another language, but once you look at a lot of different languages, it's not really clear which one is the best one. And you have to figure out which one is the best one, because picking the wrong one is highly risky, because our entire industry will have to figure that out. But there are some features to a language that are really powerful, and we really need them, and we really need them as soon as possible. The problem is that even after there's agreement on the value of a specific feature, there's still a long process before it's actually implemented in browsers. So there's a proposal, there's standardization, initial implementation, mainstream browser support, and then the long tail of browsers, right? And once the browser implements it, it's too late to take it back. So engines actually optimize for correctness and compatibility before speed, performance, or early implementations. That's why the availability looks like this, because for browsers, it's way too risky to implement something way too early. But that's not really what adoption curve looks like, because third-party libraries don't have this restriction. They get adopted before the standard is even proposed. The industry has already learned them by the time there is a standard. And at the end of the curve, we have support for new language features. But by the time the new language feature occurs and it's available, there's already 10 libraries that have the same feature. And now you have to learn those 10 libraries plus another language feature. This is the point when people are starting to have a strong reaction against standards, because they already have the feature, they already have the possibility to do this, and they don't want to learn one more thing. At Facebook, it looks something like this. We use small experimental libraries. We roll it out slowly, unless you really need it. You're not going to use it too much. And when there's a standards proposal, we quickly roll off our experimental libraries and use polyfills instead, even before the standard is filed. So most developers won't actually see these 10 different things of doing things. They will jump straight onto the standards version. And I'd like to see this happening more in our industry as a whole. So why aren't we all using just polyfills? So it's not that easy, actually. There's a few problems with it. The primary problem of adopting too early is that standards actually change a lot during the process. Polyfills will differ slightly in various ways. Libraries have these problems as well with inconsistencies between versions. So often you never actually notice this, but it does become a problem when you have third-party code that depend on the changing standard and the various versions of polyfills. And one of the reasons this is a problem is because most built-ins are on a global object or on the prototype. And you can only have, realistically, you can only really have one version at a time. And different libraries may depend on different edge cases that can't be used together. So if they go unfixed for a long time, which they actually do, unfortunately, in a lot of polyfills, more and more code starts relying on a particular version of a polyfill. So it's very important for these polyfills to stay up to date, but also the code that uses them to stay up to date. But you can package multiple versions of underscores with your app. It's not ideal, but you can. It's much more difficult with a polyfill. Another issue, which is similar to the one we brought up earlier, is that some people like to discourage polyfills because they might actually break the spec. And I'll explain what happened with string contains. So this was another era, long before ES5 and the new wave of standards. It was before Guillermo had facial hair. Where are you? So Guillermo and I was working on a framework called Mootools at the time. So Mootools was extending the built-in prototypes with some extra helper functions. And we did this way. We checked if there was an existing function, and if there wasn't, we introduced our own one. So what happens when the browsers try to implement this feature? The new version comes in, and it replaces the Mootools version, which means that the website that relies on the Mootools behavior breaks. So luckily, we learned our lesson with Mootools 1.3. So instead of overriding them conditionally, we unconditionally override any built-in version. Except the built-in version has an enumerability flag set to false, which means that you can't loop over the property to find it. So what happens with the second statement? It no longer copies the object if the browser ever implements this feature. So this is actually the reason why the browsers refuse to implement this. So they're both fixed in newer versions of Mootools. But Mootools was a popular library back then, and a lot of websites have deployed this version. So I guess we could just break them, except nobody's working on them anymore. There's no consultants working on these websites. So if a browser introduces this feature, it will break the website. This week in React, we actually checked that a string object doesn't have a key property. So if a browser ever implements a key property on a string, they might break old versions of React. And I picked two examples from libraries that I've been involved with, but I'm not the only one doing this. I'm not the only one screwing up. This is pretty easy mistakes to make. But as you can see, it's not just if you try to change prototypes. It happens in libraries all the time. And we just rename contains to includes. It's not a big deal. Browser specs will have to find a way to work around this. It's not a reason to avoid using polyfills. there's a common misunderstanding that native functions are always faster than the polyfills or library features. That's not true. So naive polyfills tend to use the native implementation if it's available. But then you can end up with the same problem that Mootles did, right? If the spec actually changes, then people using your polyfill might actually break the spec. And additionally,
Colleague Damian, this is Rebecca. We work at Automatic, which is more widely known for our open source involvement with WordPress and also WordPress.com and some other products that we have. Just to get a feel for the room, who here has worked with WordPress or has taken a look at the open source work that we're involved with? So quite a lot. That's expected. And as you probably know, WordPress is historically kind of a PHP shop, so it's potentially strange that we're at a JavaScript conference. That said, we're really excited to support the vibrant development community in South America. Earlier this week, I was at another development conference, and it's been awesome. We're actually hiring JavaScript engineers, so that's my little plug. We've been doing a lot more work with our REST API, and you probably have heard of Guillermo Rauch, Nathan Rajlich. They're great JavaScript engineers, Damian, at WordPress. If you're interested in finding more info around what we do, feel free to grab one of us in a WordPress shirt. We'll be downstairs in the dev zone and walking around during the talks and stuff. We're 100% distributed, so we don't.
Signing on Cinema 4D. Some other, I wanted to show quickly this one. Some of the interesting things that people are doing with all this stuff. Like this guy built, I think we can go to here. This guy built this, some sort of like panel in WebVR. So he's coding into this floating panel, and whatever he's like modifying something in the code, it updates the thing that he's coding on the side. So he doesn't need to remove the headset at all. He's just like, coding. He even has like, he had a new demo that he has like a webcam pointing to his hands, so he can see his hands in a panel at the bottom, and then while like coding there, like, it's funny that he can say sometimes that the cube that he's doing at the beginning, he doesn't know where it is, so he moves it. And like, yeah, he's trying to like, kind of, it's interesting to see like people like creating these things and like coding their own worlds. The last thing, I've been working on this, also this editor for a while. At the beginning, it was more like for like setting up scenes for like games, things like that. And I wasn't really sure exactly what it was for. Like for me, it was useful for like visualization of the scene that I was working on.
This example is from Scott Kellum. He created a SAS mixing in order for every one of us to have it easier when we do parallax with CSS. So you can check this one out as well. And then another great example is this one that comes with an article explaining step-by-step how to do this. And it works like this. You have those different layers, and as you scroll, all those layers are going one below the other, and it gives, again, the sensation of perspective because you are actually using perspective in CSS. Then there's option 4 in case you don't get along with CSS or you don't get along with parallax in JavaScript, or you just don't want to write one line of code, which is something called pillar. Well, pillar is not really parallax, it's something called pillar. So sometimes it is confused like parallax, but it's not parallax. And it comes with Web.js, it's a small thing, only 3 kilobytes. And it has many options for the animations, like the duration, the delay, the iteration, and many other cool stuff. And the only problem is that once you play it, you cannot replay it. That's the... Well, you can check it out later, it works. And then you add this thing which is Web.js with some brown loading images, but Web.js, something like this, full of Comic Sans and all that. And yes, it doesn't require jQuery nor JavaScript nor any kind of code. You can create these pillar effects, which is basically this. It's what the JSConf uses when all the things appear out of nowhere. And as you can see, as I scroll, the animations trigger. But the only problem is, as I scroll back again, the animations don't trigger again. That's the difference with parallax. And it doesn't give the sensation of perspective because there is no perspective in this. But you don't write a line of code in JavaScript nor CSS for additional. So what are final recommendations for parallax? Well, first of all, responsive first, then animations, then parallax, then everything. When you apply parallax to a website, you destroy the organization and the flow of the content because you begin creating relative, absolute, and fixed elements, and everything goes crazy. So if you apply parallax before making your website for mobile or responsive, then at the time you want to make it responsive, you go crazy because the whole of your website is kind of weird. So make responsive first and then add the animation and the parallax. But parallax, and especially a scroller, doesn't work really well, neither on mobile devices and on touch devices. What can you do about it? You can turn it off with Enquiry.js, and you can use Modernizer to turn it off on touch screens. Yes, because touch screens and parallax, and especially a scroller, don't get along really well. What else? It's better to animate transform property and opacity. Transform meaning scale, skew, rotate, and translate, because those are cheaper and they work better, they have better performance and opacity as well. And if you want to animate colors, you cannot use hexadecimal because you cannot go through an F to a 0. There's no transition between them. You have to use RGBA or HSL. Simply because you can go through 255 to 0, but no from F to 0. It doesn't work. That is simple changing the color mode. And don't go crazy over absolute positioning, because there's this idea that I have to absolute position everything, and it's not really necessary, because once you apply transform, the element will have a C index, and you can apply relative. The only problem with absolute positioning is really like the black sheep of the family, because it has like a rebellion in it, and it does whatever it wants. So you have to be certain that you can handle a lot of absolute elements. Otherwise, I recommend you to go for relative or fixed elements. But on the other hand, absolute and fixed have better performance than relative. So you can go from one or the other. So closing. Choose the best implementation according to your project needs. Simply, there are 1,000 ways of doing parallax, and nobody's going to tell you anything if you use pillar instead of writing 100 lines of JavaScript, or if you use a library and you don't use pillar. Whatever is great for your project, use it. And please try to keep a clean HTML, because I've seen horrible things, and I'm one of those semantics crazy people. So yeah, try to keep it clean, okay? Well, thank you very much. The slides are over there.
Thank you, Sara. 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 Thank you, Sara Okay, so thank you, Evangelina. Our next speaker is also from Argentina. He works at Yahoo, and he's actually the only coder from Yahoo that works here in Argentina. And that means that he, for sure, is really amazing. Also, he's right now working on Yahoo with Polyfill.io, as Sebastian was saying before, and also he's working now with Format.js, and his talk is actually going to be about that. He's going to be speaking about how to do internationalization on the single-page app. And what I can say is, I've looked him up on GitHub, and I saw that his picture on GitHub is a magician. So that's what I'm expecting from him. I'm expecting that he's a magician now with the code. So give a very, 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 very big round of applause to Juan Ignacio Dopazo. Thank you.
Bueno, buen día a todos. Espero que estén pasando bien. Y that's about all I'm going to say in Spanish, because I've been asked to give this talk in English. Just a second. And there we go. Well, no, that's not it. Okay, so today I want to talk to you about some tools that we've been working on at Yahoo to help you organize and develop web applications so that they're ready for users that speak different languages. And I realize that this might not be a problem that you have. You may be working on something like a local newspaper that only publishes news for Buenos Aires, so you may not need to translate Clarin.com. But if you're Yahoo and you have 800 million users spread out throughout the globe, then this is definitely a necessity. And this is a really old problem by now, and for which there are a lot of really good solutions in the server side for languages such as Java or PHP. But we found that in JavaScript there are some features that we're lacking, and that's why we started working on this. And so to put things in context, what we're trying to work on is internationalized web applications, but in the context of a modern web application. That it's a single-page application that uses JavaScript to render in the browser, so that you don't have to do a lot of reloads and make the experience faster. But an issue that we have with this approach at Yahoo is that we have a lot of content, such as news, or weather information, or photos on Flickr, that's relatively static content that we don't want to wait 1 or 2 seconds to load JavaScript in order to show that content. So to us, server-side render is crucial. We want to show the content as fast as possible. And the current infrastructure that we have for Intel, that is, for instance, we have some supporting YUI, and there's some really good projects like jQuery's globalization, is that we couldn't get this to work on the server side. So let me give you an example, a bit more concrete example. So this is a screenshot of the Flickr photo page. The photo would be actually above the screen. And as you can see, I've marked with some arrows some key parts of it. This is mostly the metadata around the image, like the description of which camera it was taken with. And the parts that I highlighted are actual dynamic data that you normally store in a database, like how many views the photo had, how many favorites or likes, when was this photo taken. And this is data that you actually normally store in a database as raw data, such as an integer or a data object. So this is data that you actually have to format somehow to display to the user, because you're not going to say, this photo was taken 2 million seconds after 1970. So let's start from the beginning with the simplest example that we can think of. So this number that you see on the screen, for 95% of you in the audience, will be the number 1002. But for most of the figures today who are from the USA, this is actually number 1 with 2 thousands. We all know this is because in Spanish, we use a dot as a delimiter for the thousandths, but in English, you use a comma as a thousand delimiter. But did you know that in French, they actually use spaces? I just learned about it because my boss is French. And don't get me started about dates. I've been working as a remote employee for over 2 years, and the number of times that I've mixed up the day and the month, I just lost count. To me, this is totally ambiguous. Is this the 11th of December, or is this November 12th? I don't know. So it turns out that we actually can gather all these little differences in the way we show and display numbers and dates in different languages, and we can put them in a big table, and that thing actually exists. And it's called the CLDR, the Unicode Common Locale Data Repository. It's maintained by the same group that actually defines the standard for the UTF-8 encoding. And what the things allow you to do is say, okay, how do I show a number or a date in Arabic or Chinese? And again, it turns out that a certain group inside TC39, which is the committee that defines the JavaScript language, realized this and worked on a standard called ECMA 402, which is the standard, the internationalization API for JavaScript. And it actually recommends that the implementations use the CLDR data. So how does this API look like? We have a Intel global object with 3 properties. Number format and data format kind of describe themselves, and Intel.collator is actually an utility for comparing strings. So you can, for instance, sort the file names in Chinese because it understands how all the UTF-8 encoding works and how you sort things in Chinese. But we're actually not using it at the moment because an implementation in pure JavaScript would be too big. The algorithm is really large and it requires a lot of data. So we realized we can't just use it in the browser. So for now, I'm not going to talk about it. So how do you actually use this? Well, it's really simple. You create an instance of Intel number format. This instance has a format method which takes a number and gives you a string with the number formatted correctly. If you don't specify anything, it'll use the locale that the user chose for the system or the browser, but you can even specify it if you want. So for instance, if your application has an option to change the language of the application. Same goes for datetime formatting. You create an instance of Intel datetime format. It also has a format method which takes the date instance and it gives you back a string with the month and the day in the right order. So again, you can specify more options if you want, and it'll give you the date formatted in a way that's more readable by human. You can even include the day of the week or a long version of the month. So now that we have this Intel API that we know will probably work in both server and browser, we started asking ourselves, okay, so in the context of single-page application, where do we use it? How do we use it? And so given a standard MVC architecture, we started asking ourselves, should we use this API in the module? Well, if we do it in the module, then we are kind of mixing up this logic between localization with the code that actually does network fetching or database access or input validation. So it kind of didn't quite fit there. So what about the controller? Well, the controller actually has your business logic, the stuff that actually makes your application what it is. So why would you put translation code there? And we ended up realizing that there's a parallel to CSS here on HTML in that we have raw data that we're trying to present somehow in a specific way to the user. The same way that you use media queries to show different styles according to the size of the device. And with that in mind, with this idea of doing things in the view and having servers at random, we started this project we're calling Format.js. It's basically a set of integrations with high-level view libraries, and you can go to format.js.io, and there's a lot of documentation and information there about both the project and the Intel API. And so, as I said, we have basically integrations with popular view engines, such as template engines like Handlebars and Dust, or React, as Sebastian was mentioning a few moments ago. So I want to show you some examples of how this works and how you can use it. And I'm going to get them in Handlebars, because I think it's probably going to be more familiar to all of you here. So in Handlebars, we have this format number helper, which takes a number and an optional second argument that allows you to say, oh, this number is actually a percentage or a specific currency. And again, same goes for date formatting. We have a format date helper, which takes a date and a couple of options to specify how you're going to show this date. And so far, if you spend a little time and think about it, you can realize, okay, we're actually formatting this data in a way that's useful for the user, but it doesn't really have to do with specific different languages. You can use it just for displaying these numbers and dates in a way that's readable, even if your website is just in one language. So now that we have this, we start asking, okay, so what's next? What more can we work on to extend this API? And as I said at the beginning of the talk, this is a problem space that has been explored a lot in server-side languages. And one very successful project was started by IBM quite a few years ago, and it's the ICU library, International Components for Unicode. And this library has been available for C++ and Java for a long time, and it's pretty much an industry standard right now. And it's, in fact, the same library that some browsers used to implement the Intel API. And the thing that we liked about the ICU library is that it has this feature called message formatting. And message formatting allows you to write these sort of complex sentences that depend on your dynamic data. And this is the kind of things that are actually kind of hard to do without some help from software. You have to start concatenating strings and doing awkward things with your code that mixes up your actual translations with your data. So, for example, in this case, we have a portion of the sentence that depends on the value of a certain value, such as num_likes in this case. And the rest is just syntax for special tokens that refer to values in your code. Again, messages already know about numbers and dates, so you also have small helpers as tokens that help you with numbers and dates. For giving a date in the past, calculate the difference between that date in the past and now, and give you that difference in a way that's human readable. So if you had a date 24 hours ago, and you specify just use format relative, it'll try to give you the best fit possible and then say yesterday, which makes sense. Or if you can actually force it to use numeric hours, but it won't just give you, just the number 24. It will give you part of a sentence that says hace 24 horas or 24 hours ago. So to wrap this up, I kind of want to take a little step back and try and answer a question that has been asked to me a lot lately. Because around a couple of months ago, we announced that we were not working on YUI anymore. And so one of the reasons that we're not working on it is because of how the JavaScript ecosystem looks like nowadays. We've seen in the last couple of years recently an explosion of JS frameworks and libraries that is really hard to keep up with. And some of them are really good, and we wanted to use them. And
that was actually pretty easy to do. So we have kind of like a kitchen sink for that here. This is the example. You can choose the number of neighbors to clusters. So this means that this will, if you put more neighbors, there will be less clusters with more edges, basically. And what you can interpolate here is between the initial state of straight lines to the bundle edges. You can play a bit with the margin, which is the stuff we added to have this kind of like bundle weight being taken care of. You can color by cluster, as I showed before, or you can color by direction. So in this case, edges that start from a blue point to a red point are like the direction. The direction is encoded in that. So here, it's not very easy to see how many edges are going from one place to the other and vice versa. So what we did also is we extended the algorithm to sort a bit the edges when you're creating the bundles, to group the edges going from one direction to the other. And so now it's a bit easier to see that about half of the edges are going from one place to the other and so on. Yeah. So on sports, the audience for sports is like pretty geeky, right? It's like they always like to know the exact stats and goals and like yellow cards and so on. So we had a lot of fun during the World Cup with this. This interactive visualization that was
And they also sell parts like Arduino. They do there are Arduinos that you can sew into clothes. I think it's the Adafruit Flora they do now. You can also do conductive thread. So you can take an Arduino, sew it into your clothes, take conductive thread, and sew in LEDs and different things like that. It's really neat, and they have instructions all over online. I worked with a 13-year-old girl who made a sweatshirt that has directionals on her back so that when she rides her bike, she can just hit a button in her sleeve, and she has an arrow on the back of her sweatshirt, which is pretty cool. And they have all the instructions for things like that on Adafruit. They make this really neat stuff. That on the top left is makeup. That's conductive makeup. So these girls put conductive material into makeup, put these LEDs on their foreheads, and it looks awesome. I mean, if you were walking down the street, it would be really startling, but it looks really neat, I think. That tie changes color with music. A lot of this stuff you maybe couldn't wear to work every day, but it's really neat. There's videos online, and like I said, they're on my blog as well.
But you know that Google and other enterprises are using fast graphic CPUs, I don't know how to say, that can be used in accelerated hardware to train neural networks. You don't need to use only JavaScript. Let's go. Sorry. And the last live demo is something that I like personally. Personally, I like, English is the same in two ways. Is that to have an hybrid approach to generate programs instead of genotypes. What is an evolutionary word? You have a world full of grass. The green is the grass. And you have animals, predators, that can take food from the grass. The predators that has a random program that say, something with some weight you can eat. If something is random, because they select the best animals in the first generation and generate new animals that notice that there are few grass now, because the animals now have better programs to eat and to move in the world. And you have better programs and better programs. Each program, each population is generated a best genotype, but this is a program. Notably, JavaScript, at least, can modify its own structure. You can modify the program in JavaScript and generate a new program. Okay. That is the end. But what is the problem with all this approach? It's a soft artificial intelligence. No baby needs to see 1,000 pictures of a cat to recognize a cat. No of this algorithm has knowledge about the domain they attack. There are only algorithms. We need to explore, like in the initial years of artificial intelligence, we need to explore the hard way of artificial intelligence. One thing that we need to do is to create really an intelligent agent that can be not play in toy worlds, but in a real world. Not in a simulated world, but in a real world. This is an image, a bad image, but it's an image for the book, the Artificial Intelligence and Modern Approach, The idea is to have an intelligent agent or maybe an artificial life agent. You don't need to pursue all intelligence in one piece, in one step. Maybe the step is to have an agent that is an artificial life agent, instead of having all the knowledge or all the intelligence we have as humans. One thing to explore them is not both unrelated things that really works in real environment, not in simulated environment. Oh, I am problem in my voice. Okay, that is the idea of the talk. All the resources, the demo, the project, and the and the different things I read are in this GitHub rep. Thanks.
Okay, so thank you, Ángel. Are you guys ready for continuing? We are like one more talk before the break, so it's just one more talk. And our next speaker is from Automatic. He works with Guillermo and the folks that spoke before from WordPress. And I really like this talk because it's about not taking things for granted. I mean, a lot of time when we're doing programming, we're copy-pasting or doing things like that. And I like the fact that he's talking about alternatives to if-else so that we don't take all those things for granted. Another interesting thing about our next speaker is that a few months back, it was his 10-year anniversary for writing his first commit on open source. And that's incredible for me, because 10 years ago, I was still in middle school. So it's amazing that it's been like 10 years for him. So one of the hard things about being the presenter is when people come with really hard last names, which is this case. So I will try to speak it okay, and we'll see. So give a big round of applause to Nikolay Bachiyski.
Hey, everybody. I will start with an old joke. So a programmer is about to leave to the grocery stores, and her husband asks her, "Honey, can you please buy some bread? And if there are any eggs, could you please buy a dozen?" And she goes to the store, she comes back, and you can imagine his surprise when she brings back a dozen loaves of bread. So we obviously have a problem here, right? So what if the problem is in the if, right? If he didn't give her any choice, there wouldn't have been any trouble, right? So unfortunately, computers are really bad at working without if clauses or without branching in general, without switch, without ternary operators and stuff like this, because they will be able to do only one thing.
Nossa, 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 nossa.
And this is not really good, right? And culturally, people, we also really like choice, because we can't live otherwise without choice, right? We really need it. So we will have to look at the problem somewhere else. And where else would be the problem? People talk about if a lot, but people rarely talk about else. And you can see that in English books, the word if is actually seen more than 10 times more than the word else, which is a lot. So people like if a lot more than else. And however, in computer programs, the word if is actually seen only 4 times more than else, which means that in computer programs we have 2.5 times more else clauses than if clauses. Why is there such a big difference between natural language and code? Because we are kind of supposed to express with code what we want to say with natural language, right? And I will try to give you a few reasons, but first, let us try to track a typical logic statement with ifs and elses, right? We have an if with condition 1, and this piece of code will be executed if condition number 1 is true, right? Then this piece of code will be executed if both conditions 1 and 2 are true, right? Then we go to an else, where we have to change our context in the sense that condition number 2 now has to be false when we are trying to read the code. And the same thing happens for the rest of the else clauses. We have to always do a context switch every time we are reading an else. And historically, context switches has been really hard, both for computers and for people doing our everyday jobs. So before we continue, let us look at what would a statement containing only if clauses would look like, without any else's. We will have to remember that this code will be executed only when the first condition is true. This code will be executed when both the first and the second conditions are true. The next piece of code will be when all of the first 3 conditions are true. And finally, the last piece of code will be executed only when all 4 conditions are true. So we don't do any context switches. We're just adding more context. And in general, for people and historically, change is bad. People never like change. But people actually like building stuff, and they like adding more and more stuff. Nobody likes migrating laptops, but everybody likes new laptops, right? And so now I will take another try at explaining why there are so many more else clauses in programming compared to in natural language. And I think the reason is that else clauses help us explain a much more complicated logic. And we use a more complex logic a lot more when we talk to computers than when we talk to people. Because computers are a lot better at understanding logic, right? And unfortunately, people are not at all great at understanding logic. We are just too lazy, we are too bored too easily, and people also fall really easy for logical fallacies. But I don't know how many times have you tried to trace an algorithm you wrote, and it is always incredibly annoying to keep all of the state in our minds. And it is because people are just inherently not great at following state. Just ask the React guys. However, people are really great at recognizing patterns. I'm pretty sure you can all read this, even though it is not any meaningful text, right? Just people are really good at, for example, as you can see, they're really good at recognizing text, even though all of the letters in the middle have been scrambled. They're also really good at recognizing faces immediately. I'm always amazed how border control officers let me in and out of countries really quickly, even though in my passport my photo looks like this. but it usually takes them like half a second to make sure and to know that I'm just the same person. And usually it takes software, because they now have those small cameras, it takes the software usually a few seconds at least. People are also really good at recognizing sounds. If you know a song, usually you can recognize it just from a few beats. And usually it takes Shazam like 15-second excerpt, right? So in a lot of sense, we are even a lot better than computers at recognizing various patterns. And science has totally confirmed that our brain is basically a huge and amazing and really fast pattern recognition machine. Actually, there have been some studies showing that our brain works really like a recursive probabilistic fractal, which actually science is trying to use for recognizing faces. So from all this, we can draw a pretty simple rule that if in our programs we use more patterns and less else clauses, it will be much easier and it will take a lot less time for the person who reads them to understand what is going on. And by patterns, I certainly not necessarily mean design patterns from the Genga 4 book, if you're fans of those. In my remaining time, I will try to show you a few examples of tricks about how you can eliminate else clauses from your programs. The first one, which is probably the most common and easiest, is to emphasize the essential part or the main flow of our code. Here is a really typical example where if some data is valid, we do something with it, and if it's not, we return false, right? Or no, sorry. I'm sure everybody has written a lot of code for situations like this. And see, the essential part of the code is now in pink, and this is where we actually process the data. The rest is like, there is a really neat term called accidental complexity, which is all of the stuff we need to write, all of the plumbing we need to put so that our programs work the way we intended them. And here is a very quick way to make sure that our essential complexity, the important part of the code, is emphasized. If we first bail if there are any errors, we can achieve a few things. First, all of our essential code can be together. Also, it will not be indented somewhere further in our program, so that we know if something is in the main indentation level, it is probably something important and not just error reporting code or error checking code. Another trick to eliminate else clauses is to use polymorphism. Actually, you used to think that polymorphism was a multi-headed monster from the Greek mythology, but it turned out that it is the method of being able to use the same logic for data with different types. And I'll give you another example here. I'm sure everybody has done something like this. We have to render a field or whatever object, and this field can be in different types. Like in our case, if it's a text, we render an input. If it's a number, we have our special component. If it's a text area, we render a text area, or we throw some exception. So if our goal is to eliminate else clauses here, it will be pretty hard. And we can go back to polymorphism, which, to remind you, is to find a piece of code which can work somehow with any type. And the common pattern here is that for each type, we have a specific component we just render. And for example, instead of keeping all of our structure in if clauses, we can keep it in an object, and we can use the type as a key. I'm sure all of you have done this a lot of times. It is not rocket science, and I see a lot of people actually do it. But it's important to remember those tricks when we have a bigger application or we have a really complicated expression and we wanna eliminate else's one by one. So morphism, there are a ton of ideas there about how to do that. So people really love patterns, and actually they will often see patterns where no patterns actually exist. For example, there are experiments showing that if you start showing people random dots, when people are overwhelmed, they will actually start seeing patterns because our brain cannot handle a really complicated world. Our brain is always trying to make sense of the world around us. And for example, when you get more and more dots, which are totally random, for example here, it turns out that a lot of people do not see random dots, but they start seeing poodles, right? Or you've seen people looking at the clouds and seeing, I don't know, monsters, bears, or people looking at already drunken coffee cups and trying to predict the future. It's our way of telling, it's our way of, that our brain tells us, oh, it's all too complicated. I want to make it simple again. And here is an example where it could be a problem in pattern in few places. So it is really important to have our patterns in a much simpler ways. Like for example, if this was in an object, it wouldn't be so easy for us to break the pattern. The next trick is to put more focus on the action we are doing and not so much on the intricacies of the logic. Here is an example. Here is the logic of a kid in the spring season, basically anywhere in the world. If it's a weekday, it goes to school. If it's not a weekday, but if it's a Saturday, it plays football. And if it's raining, it watches TV because they can't play football. And on Sunday, obviously, kids have to do their homework sometimes. And if it's winter, we, like bears, really like to hibernate. So how can we make this simpler? Because when you look at it, you don't see any actual pattern. It is just a random logic going back and forth. And here is what we can do. We can just focus on the action themselves and not so much on the conditions. Humans, as we are pretty bad at keeping state, so they usually try to avoid it. And very often we are pretty explicit in what we say. So we will usually not say that, oh, if it is spring, I will go, and if it's a weekday, I will go somewhere. Instead, we usually say, oh, on a spring Saturday, I would go play football. And you can see here that it is really easy to see the pattern of all the important stuff. And these are the actions, right? Sometimes it is really hard to escape the conditionals. And we don't have to go into too much trouble. So if there is no visible way to escape from them, at least the least we can do is to simplify and make everything shorter by extracting stuff. We can extract methods. For example, this monstrous thing can just happen this. by extracting a function in the middle and giving it a proper name. Or we can extract a conditional and again giving it a proper name. If people tell you that they don't like so much abstraction, it is really important to point out that this is indirection and not abstraction. We're not abstracting things too much. We're just putting it inside in a very well-named functions, and usually it is pretty obvious what do they do. As a closing, I would like to say that writing code is actually a lot closer to user experience and usability than we think. Because across us sits a normal person. And we need to make sure that when they read our code, it is easy for them to understand, and it doesn't take them too much time. In the end, people are a lot more important than computers. And as Mr. Abelson said in the really great structure and interpretation of computer programs, that computer programs are written for people to read and only accidentally for machines to execute. Thank you.
Thank you, Nikolay, for the talk. I've just seen some of the videos that are going live, and I saw that if it looks like I'm a little bit overweight, as Susana Jimenez says, it's because the TV makes you fatter like 10 pounds. It's not, that's the only reason. So right now, we'll have a short talk from the people from Mango. They are presenting something today, and they are one of our sponsors. So a big round of applause to Pablo Sánchez.
Hola, gracias. Bueno, Mango es un producto para Latinoamérica, así que voy a hablar en español. Tal cual decían las pelotitas que tenían en sus bolsas de JSConf, en Mango creemos que recibir pagos online y aceptar pagos online debería ser más simple. Tiene que ser más simple. No puede ser algo que nos cause estrés. Y por eso desarrollamos Mango y un set de tools específicamente apuntados a hacerle la vida más fácil a los responsables de los negocios o organizaciones que quieran recibir pagos online, pero también a los developers, especialmente a los developers, ¿sí? Entonces, hemos creado una API REST robusta, flexible, fácil de implementar. Tenemos librerías y SDKs específicos para diferentes tipos de lenguajes en los que quieran desarrollar sus aplicaciones, ya sean plataformas web, aplicaciones mobile nativas, a donde quieran poder implementar una solución de pagos como Mango. Un panel a donde pueden hacer debugging al mismo tiempo que la gente de administración del comercio o la organización puede ver datos que le interesan a ellos, pero que ustedes pueden utilizar para hacer debugging. Y el entorno de Sandbox, que es exactamente idéntico al de producción, para que puedan hacer una prueba exhaustiva de lo que están desarrollando, ¿sí? Estamos muy contentos, seguramente conocen a algunos de los chicos del equipo, estamos acá todos. Estamos muy contentos de anunciar acá que el lunes 1 de diciembre lanzamos oficialmente Mango en Argentina y en beta privado en Brasil y Colombia. Así que los invitamos. Los invitamos a que puedan entrar a nuestro nuevo sitio que lanzamos hoy en la mañana, getmango.com, que nos busquen en todo el evento. Estamos repartidos para hacernos las consultas que quieran sobre el producto y esperamos que tengan una buena experiencia implementándolo. Gracias.
Bueno, gracias Pablo. Como todos ustedes ya se están levantando, es el tiempo del break. 3:20 si pueden, empecemos subiendo ya, que 3:30 sigue. Gracias.
Won't you take the fear away and be my lover in the rain, like a picture on a frame. Be my lover in the rain. It's the same old wicked games, like a broken ball and chain. Take the pleasure and the pain. And I want you to watching you closely. There's nothing that I can do. Such indecision. I'm getting caught up in you. You're under my skin now. I wanna feel time with you. Taking your time now. I want it, I want it. You're taking your time now. And I want you to. From the moment I saw it coming, I thought that I could leave it all behind. From the moment I saw it coming, I thought that it would take it off my mind. I thought that it would take it off my mind. From the moment I saw it coming. From the moment I saw it coming, I thought that it would take it off my mind. out of my head. I couldn't have you if I said. But things still get out of my head. I couldn't have you if I said. But things still get out of my head. Won't be the last, won't be that one. Without your touch, I know it's done. Without your touch, without your touch. 3, 2, 5, it's what's left to survive. 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 It's what's left. It's what's left. It's what's left. It's what's left. Without your touch. Without your touch. Without your touch. Without your touch.
Everybody is ready to continue? Okay. I'm still kind of asleep. That's why I still have my coffee. I actually asked for the coffee, and they gave me something like this, and I was like, yeah, I need to keep awake, so give me a little bit more. So I asked to make it full, but I really need the coffee. But now I'm here to talk about our next speaker. Our next speaker works at Stripe, and he has been doing a lot of open source stuff. He has worked with YepNope.js. He has done CSS color guard, and also he has done message format.js. So without further introduction, please give a lot of applause to Alex Sexton. Thank you.
Hey everyone, that looks good. I think they're gonna stretch it. I need your, you did that earlier, right? Oh, yeah, I have the power. Stretchy. This is responsive slides. This is a media query for Argentinian widescreen. I don't think it's right now. All right, we look pretty good now. So I'm going to be talking about component libraries, and you might say, what's a component library? Which is what everyone at my company said when I said, hey, let's build a component library. So I tried to make it easier for them. Everyone had heard of Bootstrap, and so at work I started working on something called Bootstripe. It's pretty good. You'll get it. It'll come to you. So I encourage you to build your own component library, mainly so you get to make your own something strap, JSConf strap, whatever you want to do. Stripe strap didn't work quite as well as Bootstripe, so that's what we went with. But why write one at all? You could just build your application, and then when you get to a button, you style the button, and then when you get to a drop-down, you style the drop-down, just like we've made web applications for a really long time. So I've prepared a list of facts that are definitely true about CSS. The first CSS fact is that once you write a line of CSS, it can never be deleted. It sounds like a myth, but if you think about your app, you're always just a little too scared to remove code. And so you just add new classes to go over those ones. So I like to call CSS an append-only language. That's good. You get code like this. This is my favorite. I always see blocks like this. You put this on a div, it literally does nothing. But you're like, well, is it overriding the padding? I'm just going to leave this here. This is fine, I think. It's not hurting anyone, so never remove it. Yeah. So fact 2 is preprocessors are great as long as you know exactly what the output. This is my favorite way of looking at nesting. Very common output. For you gzip lovers, this is like your best case scenario, though, so that's pretty great. CSS fact 3 is that no two people write CSS in a similar way. I feel like I work with some of the smartest people in the universe, and this is probably about as best as I could ask for. Literally every type of casing, and then some casings that don't actually exist. So yeah, I'm sure you recognize the naming schemes from your own code, and that's why you're laughing. So CSS fact 4 is you cannot test CSS. It doesn't run in a way that you can get stuff out. There's not really a good joke for this one, so I'll move to CSS 5. So you can't upgrade to a new version of Bootstrap without an animal sacrifice. And I decided not to include an image for that one. So deleting code and testing actually go hand in hand. The easiest way to feel comfortable deleting something is to make sure that you have tests to make sure it doesn't break something whenever you delete it. So component libraries are well-tested and highly reusable libraries for UI components. They would be ridiculous to test if you did them inside of your application. So in a component library, you're often testing that when you hover and it's active and the keyboard focuses on and you're looking sideways, that the thing comes around the edges of the button correctly. And if you did that inside of your application every time you had a button, that would be ridiculous. But luckily, with a component library, you can kind of focus on those nice, detailed things. And so the reason why this is important is because this is me on a good day. It's probably my best outfit. I look really sharp. I had a recent haircut. I'm next to something involving art. It looks like everything even matches. My clothes are on the right direction. It's a pretty good day for me. The code that I read on this day is going to be well-intentioned. I'm clear thinking, and I'm going to do things for the right reason. This is me on a normal day. This is about 90% of the time, 99% of the time maybe. And component libraries are all about making sure that this version of yourself doesn't ruin the app for everybody. So use your best days to build up components that you can use mindlessly on your worst days. So you can do things like keyboard accessibility. Oh, I put in a fancy thing. Oh, responsiveness. There you go. I don't know actually how Keynote transitions work, so forgive me. That was sweet. Focus states. It's the only way focus states can be interesting is if they sparkle. So active, hover, focus, like I talked about before, and that's real. We really have styles that if you have been using your keyboard and you're pressing down and your mouse happens to be over something, like you can't have some weird state. That's a real state, and you've never considered it before, I hope. But I hope you do in the future because of this stuff. So it turns this very crappy but well-intentioned Mario clay, it's fully sculpted. Like there was no instruction manual. There's nothing anyone can do to help you make your perfect, fairly flawed Mario. And it turns that into this, which is, you have building blocks, you have pieces, and you have instructions on how to put it all together. And so we do the same thing for Bootstrap. We have this documentation that looks beautiful on this screen. And we have what something is, we have how to use it, we have examples of it being used. And that really helps create consistency for developers on how they integrate things, but also helps create consistency for your end users. Every time that they encounter a button, every time they encounter a nav menu, they're going to know it's going to work the same way each time. Bonus, everyone has like the admin toolbar backend thing, and it's really great that now whenever we build these stupid, crappy internal applications, you can just use your thing and it kind of looks like you tried. That's just bonus. So how can you make a component library? Or more specifically, how can I make a component library and it's going to be any better than just using Bootstrap out of the box? And that's a good question. You probably could use Bootstrap for a lot of stuff, but Bootstrap's core competency is genericness. It wants to be the baseline. It has no styles on buttons, and it's fairly accessible, but everything looks the same, and people are pretty tired of Bootstrap websites by now. If you get in on Bootstrap 4 early enough, maybe that'll be cool for like a month or two. So first thing you want to do is choose a preprocessor. Not strictly necessary, but really helps if you're parsing CSS. You can do a lot of the testing things that we're going to talk about. At Stripe, we didn't choose a very normal one. We wrote our own called KFCSS. You guys have KFC here? Either way. So KFCSS is actually just a set of modules on top of Rework CSS. So mostly we're using open source plugins to do a lot of the things that you like. It'd be similar to like Myth, if people use Myth. It tries to model CSS4 as closely as possible. So this would be really good for Seb's talk, where you're kind of more polyfilling the future than you are kind of creating your own magic. We also kill things like extend so we don't get crazy nesting, and we just deal with writing a class name twice. Suit CSS is a good starting point. We don't use Suit out of the box, but we kind of forked it and made it work for our needs. This is from Nicolás out of Twitter, and this is really good for creating encapsulated CSS components. So you can reason about your code in nice little cool blocks that you know exactly what they're doing. So here's the example on the naming conventions, which is mostly what Zeus CSS is a set of naming conventions. And you can say this is a component, and people, like, their eyes bleed whenever there's a capital class name, but you get used to it, I promise. It's kind of like when everyone tells you JSX is so ugly, and then they use it, and they're like, oh, JSX is actually pretty cool. This is great because you can always tell what is a component in your classes and what isn't. And then you have structured ways of saying this is a modification, or this is a descendant, or this is something else. And so you can kind of get rid of this whole problem that we had earlier. You can add in your own checks to your system, and I'd encourage you to add in checks into, like, you can write rework plugins, more or less, if you choose rework, in order to jump into your CSS and pick out things that are important to your organization. One thing that bugged me at work is color checking. So I wrote CSS color guard, if you've seen that. And CSS color guard is actually fairly useless, but I thought it was a cool idea, and we use it kind of at CI, continuous integration testing time. But to show a good example, here's Guillermo's post today from on Facebook about the road towards yesterday, road towards JavaScript. And let's say you wanted to know the color of those 3 buttons. You could use DevTools, but all of us have gone through the real way that we would do this, which is to zoom into 1,000,000%. I drop the darkest middle point of the E, and then it works every time. That's definitely going to be the correct hex code. So luckily, there is an algorithm that people in the television industry created called CIEDE 2000. Sounds like a robot, which is also cool. They wrote this hella mathy formula for figuring out the differences of colors to humans. So something with a low score would be very similar. A 0 would be the same color. And so like yellows are kind of harder to discern the differences between than something like blue. And so it's not actually just like compared to hex values. And so you can get this really fine-grained way of saying how similar are these 2 colors. And then you can yell at your coworkers automatically and say, like, hey, this blue clearly should be Facebook blue, and you're like 2 hex characters off. How about you just switch it to our style guide color? Also, you're fired. We have a lot of APIs at Stripe. We have an API for firing people, so it's very simple. The best part about writing CSS color guard, let's go back to that page. I'm going to run through all these again. The CIED 2000 algorithm, this super mathy one, that was an NPM module. So I got all the credit, and someone else had to do all the math. Pro tip. So here's an example of one of our test pages. So you can test CSS as long as you're testing something very small, well-defined, and relatively declaratively. So this is 2 ways of marking up a switcher or a toggle. So you could kind of toggle between those 3 things. And we have a disabled state because there's that, and we have an active state. We're using the isActive and isDisabled, which is from the Suit CSS naming scheme. And you can kind of see the 3 different ways that those look. We're not clicking on anything, we're not doing anything. But we can run that through our CI server. We can take a screenshot of it, and we can make sure that it doesn't change unless we wanted it to change. So if you accidentally change the base blue color, you accidentally change your pseudo states. And that way you don't have to use a mouse to go in and then drag over it and then try to take a screenshot exactly as you click down with the fake mouse and then pull out. And it's never good, especially when you're dealing with SAS Labs or something that you don't even have control over. So that's never good. So you can do all this, and then you actually get a much bigger page with all the different states. And like I said before, there is the isActive focus hovered state there, and it looks different than the other states, and it's correct and good. So we run this test every time we make a commit. And if anything changes, say the margin around the buttons, we get this diff that says, hey, did you mean to do this? And that'll actually fail the build. If we want, we can commit a new image. and say, we intended to do this. And then you can actually see the change that happens. And this seems like a cool video that I put together. But this is actually just the onion skin swiper from GitHub. So now we have a rule that in order to make a change in Bootstrap, a designer must sign off on any image changes. So now every time anything visually changes in our entire library, it either fails a build because it wasn't supposed to happen, or a designer says, this looks correct and it's OK.
But it basically involves creating a Sauce Labs account and Travis has a way of encrypting environment variables, so you can encrypt your username and your authentication key, and then it knows which repository you're accessing. So there's an example of what Travis CI's matrix would look like. It's a little blurry, but we're specifying browser name, browser version, and a matrix style, and a couple tests are failing there, so we'd want to go in there and clean that up, right? So you'll need to create a Sauce Labs account. There's free ones. They're called Open Sauce. And you can basically create as many of those as you want. So Zool integrates with Sauce Labs, like I said, by checking the environment variable. And so somewhat annoying, but you have to create a new Sauce Labs account for every module created. I'm going to have to ping their support on that pretty soon or something, but it's a little annoying. My 1Password looks like this by now, so it's kind of ridiculous. Hopefully they'll make that process easier soon. So then, again, of course, hopefully in the end, you get nice.
It's essentially autocomplete for translations. So this is the text that a translator would potentially have to translate. And here is the machine's best guess. And so it's relatively good. The guesses are relatively good. And, but sometimes when it's a little less sure, it'll present a few options. And in this case, it's not actually correct. Or this is perhaps a better translation. And then you can kind of accept the rest. So, so again, that was something that we didn't design for. When we built Quill, we didn't think about ways to improve the experience for a translator. But this is something that you could build. And I guess the point, the main point of Quill is its API, and it's able to do this because it has one. And so to conclude, I kind of want to step back from Quill specifically and talk about APIs in general. If you think about products and everything as a graph, then if you just offer something without an API, it's essentially a terminal node. That's all you're going to get. But if you offer an API, then it could be part of a larger offering, and it could spawn many more products and many more ideas. So when you're building kind of those products and services, I encourage you to think about that. If you want your offering to be kind of that's all the offering is, or if you want to kind of open the doors for something else that you didn't think of.
The rest of the talks and some more awesome stuff. So 15 minutes, please be punctual. Thank you.
Dale.
safe and sound. I can feel your cup. You know my river won't evaporate. This world we still appreciate. You could be my luck. Even in a hurricane of frowns, I know that we'll be safe and sound. We're safe and sound. We're safe and sound. We're safe and sound. I could show you love in a tidal wave of mystery. You'll still be standing next to me. You could be my luck. Even if we're 6 feet underground, I know that we'll be safe and sound. We're safe and sound. I could lift you up. I could show you what you wanna see and take you where you wanna be. You could be my luck. Even if the sky is falling down, I know that we'll be safe and sound. I can lift you up. I can show you what you wanna see and take you where you wanna be. You could be my luck. Even if the sky is falling down, I know that we'll be safe and sound. We're safe and sound. We're safe and sound. We're safe and sound.
the whole mindset. So this is, for me, really, really, really nice to be part of this. So this is the basic introduction. Let's do some demos and see if this is working. Let's cross fingers. This is hard. This is the first one. This is a sumo bot. This is all, the whole project is open source. So you can download the CAD files and print the parts using a 3D printer or a laser cutter. And I'm using in this project the Spark microcontroller. So the Spark is connected to Wi-Fi. I'm going to check if everything is working right now. So I'm going to plug it. These will connect to the Spark cloud. There is a cloud that will accept this robot to the internet. Let's see, he's trying to connect to the network. Okay, it's connected. And I'm going to run the application. Let me see. Oops. So let me execute this really quick. Connecting. So my computer right now will act as a web server. Okay, let me show really quick. I wanted to execute it from the cell phone, but the connection is not working right now. But I can send comments to the bot. I'm using the manual version because I can. Whoa! Thanks. Nice catch. Well, I wanted to control the boat using the smartwatch. Maybe later the internet is not working right now. But well, no problem. This is the other project. It's called Nodecopter. It's an art run. Let's see if it's connected. It is good. So Sara will told you this afternoon. This is like running a web server, so I can control this from a web application running Express and Socket.io. Let me see if I can control it. So this has like a Wi-Fi hotspot, so I need to connect to the Wi-Fi hotspot and do the magic, but it's not working. Nice. Okay. Okay, it seems it's working. So meanwhile this is connected, I can show you other projects. This one is gaita or cuisi. Is like a Colombian folk instrument mainly used to play the gaita, to play cumbia. Anyone heard cumbia? Anyone like cumbia? Cumbia villera or, oh great, that's good. So this is like running a web server. I'm using the BeagleBone Black. This has like a mic, so each time I talk or it sends a noise, he will like change the color pattern. But the idea is like you can hack your own musical instrument and create like really fun stuff. So let me see if I can play it. Hey, thanks. It's working. Woo! So oops. Let's see if the other are working meanwhile. Oh, perfect. I think we are on time. So I'm not a musician, but I like some music projects. This is one I've been working on. This is a drum kit. So I'm using like a pad, like you can play some sound. Can I have audio here? Oh, I have a real, great, thanks. Perfect, thank you. Let me plug it in. So what I'm doing with this project is mapping the keys with some samples from a Roland real drum kit, so you can build your own instrument. So let me play it. I'm gonna execute it. And it's working. Sounds good. Okay. So you can create music even with electronics. It's another instrument that you can build. Okay, this is connected right now. This is so unstable right now because I crashed it like multiple times. I'm not a good pilot, but yeah, can I see the screen, please? Can you focus the screen, not the video? What? I want to show, okay. So yeah, let me check the Express application. Okay. So I'm going to execute it's an application called the web flag, so you can control, you can run like an Express server, and using Socket.io, you will be able to control a notebot from your web browser. So I'm going to enter to Express application. Okay, this is the camera of the drone. Right now, this is the thing. Maybe it will crash, but I'm going to try to fly it. So, stay away. Whoa! Go up, go up, go up, go up, go up, go up. No, not to me, not to me, not to me, not to me. Okay. Woo! It worked. And this isn't like web application, just know that it's flying and you can see in real time. Just really quickly, you can ask what it is. This is not the R2D2 head. I don't kill R2D2. Have you heard about an instrument called the theremin? It's kind of a species of theremin. Let me see if it's working. So what I'm doing in this project is I'm going to run it real quick. Studio, okay. I'm using the right sensor to control the notes, the frequency, and the left sensor. They are ultrasonic sensors, so it measures distance. So I'm using it to control sound. So can I see the? Okay, thank you. So let me check this. Not easy. Is the second one. So I'm using a web application written by Substack. It's working. So I'm changing the frequency only using the distance, so I can play some kind of music, and then I can add some really nice distortion. So you can play with, you can create different experiences, maybe in a party or something, when you can use sensors and control the lights, and as you can see, the frequency of the sound is changing. This is all written in JavaScript, so you can create your music like your music function, so it would work really good. And the last one was the clumsy biped. This one, I have time to play it, or we're done? Done? Okay. So this is a biped. It's using 8 servos. It seems it will work, but time is over, right? Okay, it's sad. Okay. Let's see. I'm trying to teach him like to walk, but he's not a really good walker. So what I call it, like the clumsy biped. So it has like some problem walking, but let me check if I can. If I can run really quickly here. Okay. So this is not like, he's trying to walk, but he's not a really good walker, so you need to teach him. Oh, he's trying to dance. So it's really difficult to control like the 8 servos at the same time, but I'm using like Johnny 5 in all of the experiments, so it's a really powerful like library. If someone want to play with it later, we are going to stay here until December 10th, and the main idea is like to help with the local community and to have some notebooks experience here. So we brought some Arduino kits, so the idea is like the next week maybe we are going to give a workshop here. And since I received my first kit as a gift in an event, I want to give this like as a gift for the community too. So if you want to keep this robot in Argentina and keep playing with it. So I've been in contact with Alejandro Oviedo. He's one of the leaders of the Node School community in Buenos Aires. So Alejandro, if you are here, this is for you and this is for the community. So this is my presentation, and I will invite you that keep working together, keep working in community, and please, thank you and welcome to JSConf Colombia next year. See you there. So, Alejandro, pick it up. If you are here, let me know, and this is for the community. Thank you.
So, thank you, Julián. Also, thank you for the present. This is mine, right? I want to fly it. I mean, I like it. It's mine. So, I guess not. Anyway, so we are again behind schedule. Thank you, Julián. But the demos were really cool, so it was worth it. Our next speaker is from Uruguay. So this is a moment where I would like to make the politically incorrect comments like Mate is ours, Carlos Gardel is from Argentina as well, but Guillermo Rauch doesn't let me, so I won't say that because everybody knows it. So now that we all know that, let me introduce our next speaker. As I said, he's from Uruguay. He works with RabbitMQ on Pivotal. He's the co-author of RabbitMQ in Action. And he's going to talk about how to make distributed data integration systems with RabbitMQ. So give a big round of applause to Alvaró Videla.
¿Cómo? No. El gesto mágico, por favor, de achicar la pantallita. Gracias. Okay, so hello. I'm going to give the talk in English, but first I have to say some stuff in Spanish, considering what Mr. Gonto just said to introduce me. So, no tengo un mate bajo del brazo, pero sí soy uruguayo. Soy de los uruguayos espías que manda el gobierno de Uruguay, que Capusotto tanto les ha explicado.
tengo mis championes y digo botija en vez de chabón. Y bueno, como buen uruguayo, me tocó cruzar hoy por el Tigre, o sea, venía de Nueva Palmira, así que soy el único uruguayo que cuando cruza Argentina llega con jet lag, porque me pasearon por cuánto río hay en el delta del Paraná, o no sé ni cómo se llama la región esa. En fin. Y bueno, el último comentario ya lo hice en la conferencia de PHP, que está el amigo acá que lo organizó. Hace como 4 años que no venía al Río de la Plata, y uno de los cambios que noté es que River se empezó a escribir con B hace poco, pero un detalle nada más. ¿Ah? Ojo, que conste que a mí me gusta River Plate. Así que... Y para los que se están peleando por saber, los Timbers es el equipo de la Gata Fernández en Estados Unidos. Así que dale que tarde. Bueno, disculpen todo lo uncon de mi introducción. So the talk of today is about RabbitMQ, how to build a data ingestion system with Rabbit. This is a 1-hour talk that I should compress into 20 minutes. So let's see how it goes, plus my jet lag. That's the book, contacts, whatever. The idea of the talk is to kind of say what can be done with Rabbit, not necessarily how to do it. We have plenty of tutorials on our documentation on the website, so if you really want to see the code for Node.js, of course, Java, PHP, Python, Clojure, .NET, Haskell, whatever, we have it there. And yeah, this is an actual tweet. What even is a RabbitMQ? So Rabbit is a multi-protocol messaging server. It supports AMQP by default. Basically, the big banks in the States created AMQP or started the AMQP protocol or project as a way to spend less money. Not sure how that succeeded there in doing that, considering the 2008 crisis, but that's outside of the conf. And yeah, Rabbit supports AMQP by default, and then MQTT, which is a protocol like for the Internet of Things and stuff like he was just showing. It's also used, for example, by the chat on Facebook, on iOS. They use MQTT. And Stomp is a text-based protocol that, for example, is used at the New York Times for WebSocket because it's a text-based protocol. So in JavaScript, if you want to do browser messaging, Stomp is the best protocol for that. And it's also used in Switzerland at CERN, for example. So if you want to read more, there's the blog post. In Rabbit, it's a polyglot system, so you can connect from all these clients and more. Of course, Node, Ruby, Erlang, PHP, Java, .NET, Clojure, Haskell, and many more. The thing is that most of these clients, or actually, yeah, all of them are maintained by the RabbitMQ team. So they are all well-maintained libraries, or that's what we want to believe. I'm the responsible for the PHP library, for example. Yeah, is there anybody using Rabbit? Yes, Instagram, Indeed, Telefonica, Mercado Libre, New York Times, Mozilla, the company that does the effect, the special effect for the Lord of the Rings, or now the Hobbit, they use Rabbit, and many other companies. Next, how do you actually use Rabbit? So I have a simulator here. This is the only probably JavaScript part of my talk. By the way, I don't know. I don't want to. Let's move on. Let's not get into finals of South American championships. So let's focus on the talk. Woo. So in Rabbit, what you want to do usually is to have a producer that wants to send data to a consumer. And the way to that's the basic thing that Rabbit should do, right? So then the consumer can subscribe to the queue, and there you can get the messages from the queue to the consumer. And if you want to speed up things, like for example, you go to the subte, metro, and you want to buy tickets, and it's kind of going a bit slow, then of course the government will add more people there to work and sell you tickets faster. They always have coin and like change. That's very typical to get coins there. And then Rabbit will do I mean, if you have more consumers, it will do round robin and send messages across the consumers doing kinda round robin. So this is the basics of an NQP. You have the producer that wants to send data to some consumers. The data is sent to an exchange, that's the address, and from the exchange is routed to the queue. Just to explain this a bit more, and then I move on with the talk, you may wonder why you need an exchange. Why just not send the data straight to the queue? Like, why don't take, ¿por qué no te tomaste un buquebús hoy en vez del coso ese en el Delta? En fin. From Switzerland, when you go to buy tickets to the train station, you can say, I want international tickets, or I want local tickets. So when you arrive to the station and you say, I want to buy an international one, they will give you, they will print a ticket saying you are on the queue for international, which, as usual in Switzerland, they are not so friendly with foreigners, so they don't have anybody to sell international tickets. But if you go and buy, they are really friendly with foreigners, by the way. And if you want to buy local tickets, then they go to the other queue. And of course, you can add consumers to this queue. That's as usual. So the exchange, in the case of the direct exchange, is choosing queues based on the routing keys. Here, you cannot see it so well, but it says international, and the other binding key says local. So in messaging, you usually have an envelope that has like a routing key in this case, like the address where you want to send the message, and you have the content. RabbitMQ should not check the content as the guy from the post office should not do. The message Rabbit will just check this envelope, headers, routing keys, and whatnot, and decide where to route the messages. And with the other algorithms, we can do more advanced things, like with the topic exchange, which I'm not going to show because it's going to take a bit of time, you can actually use some kind of patterns to decide how to route messages. So it's a bit more advanced. If you use logging, for example, it's really easy to say, I want to listen to logs which are warnings coming from the application 1 on server 1, for example, and I only want to listen for logs coming from server 2, but whatever they are, warnings, error, info, I don't care. You can use some patterns to implement that. So that's how NQP kind of works. We have the producer sending data to consumer. The exchange will have an algorithm that will route messages to queues, and then the data will arrive to the queue. In Rabbit or in NQP, there are many things that we can add to this mix. For example, consumers on this side can decide to ACK the message. That is to confirm to the broker that the message was successfully processed. The publisher can request the same from the broker. The publisher can request to the broker to confirm when an F-sync was sent to the hard drive to actually persist the messages. RabbitMQ will do that every 200 milliseconds. If, let's say, you have a cluster with 5 rabbits and you told Rabbit to replicate to 3 nodes, when those 3 nodes did the F-sync, then Rabbit will send this confirmation back to the publisher. And some more things. Based on this is what we can implement the problem solution that I want to show you. So let's say we have a distributed app. If you can see that this is related to the Amazon availability zones or regions, actually. So you have Brazil, Virginia, Ireland, and Singapore. Or Uruguay, because if you leave Uruguay, nobody knows what Uruguay is, except maybe Argentinians. They know it's a province to the east. Besides that, like you go to holidays there. And Norway, did you say Norway? Yeah, Norway. Anyway, so you want to send all this stuff. I mean, you are collecting data here. Think, for example, you have a game application. This happened, it's a real use case. Some user had their game app collecting data all over the world, and they wanted to analyze the logs in the state, probably to detect cheating or stuff like that. So they want to replicate the data. This looks like JavaScript, but actually it's Erlang with a very interesting syntax. Sorry for showing some Erlang here. How do you send data to Rabbit? You get a connection and you get a channel, and of course there are options to open the connection. I'm not going to go there. And once you have a channel, you will send a command saying exchange declare, the exchange name, and the type of the exchange, direct in this case. And then, if you cannot read that, this is the very reason why Node.js kind of beat Erlang on popularity. Who can read that? So I'm sending a message, basic publish, to some exchange, and the message has some properties and some payload. And on the consumer side, I do the same. I get connection and channel, and on the channel, I create an exchange, I create a queue, and then I connect the queue to the exchange. Once I have that, I tell Rabbit I want to start consuming messages, and then I start looping to get the messages from Rabbit and do something with the messages. So this is all nice. We have this deployed on each region in the world, but we want to replicate data. So we want to be hired by the NSA with all things and send everything to the States. How do we do that? Of course, we can have our own solution. As you can see, one exchange can have more than one queue bound to it. So we can just add a parallel process that is just replicating data coming into an exchange to a remote machine. But the problems that we may have with that is that what happens if the remote server is offline, like how we prevent unbound local buffers. Like we cannot replicate data, but we are collecting them in queues, and then those queues start growing and growing and growing. We may run out of disk space or memory or something like that. How do we prevent message loss? What happens if the message was written to the network, but the remote machine crashed? Then we lost the message, or we were not even able to write to the network or whatever. There is a meteorite falling on the other side of the world, or I don't know. How do we prevent to send the data that we don't want there anymore? Like in messaging, it's very common that we have, let's say, 10,000 messages per second or 100,000 messages per second. Those numbers in messaging are not big numbers. Like when people say this is a scale problem and they mention 1 billion messages per day, that's nothing. 1 billion messages per day is actually 11,000 per second. So for messaging apps, it's low, actually. That means some data can be really old, and we don't want it on the remote machine, for example. Of course, we can implement all this stuff with Rabbit on ourselves, but Rabbit offers a better solution, which is the Federation plugin. This is a plugin that comes directly with Rabbit. When you install Rabbit, you can just enable the plugin, and it can do replication across many data centers. You can mix Erlang and RabbitMQ versions. Yeah, sorry, Rabbit is not written in Node. Supports network partition. That is, if the remote server is offline, this federation thing knows what to do, or should know what to do. And you can tell what to federate. If you enable federation, doesn't mean every message will be replicated. You can tell Rabbit, I want to replicate this and not that, for example. And you can create topologies like this one. You can say, this is an upstream server, and the data will flow to the downstream servers in like this topology. You can do like a circle and tell Rabbit how many hops the messages can do, so you don't have like an infinite loop. And yeah, it's just a plugin, and internally it's just using queues and exchanges, so it's not something magical that you couldn't implement. The thing is, it's really there. Many companies use it actually in production. Big companies, like the one in charge of paying the salaries in the States, is using this. So if this doesn't work, I will probably not be here. I will be floating in the Tigre Delta, maybe, I don't know. Anyway, this is very dark now. It's the lack of mate. You know, when an Uruguayan starts lacking mate, it's like, I'm kind of shaky now. And you can configure it at runtime using parameters and policies. Those commands enable the plugin and let you manage the plugin. And then how do you actually federate something? You just tell Rabbit, I want to create a parameter of the type federation upstream called my upstream, and then you tell Yuri where to connect. And that's it. Rabbit will know how to connect to that. And then you tell Rabbit, every exchange whose name starts with AMQ dot, in this example, it could be images, logs, whatever, that exchange will be federated and replicated. And that's it. By doing that, Rabbit will set up like this thing here. This is your upstream server, the federated one. Imagine this link is not there. Let's say this is Brazil and that's the States. You have your publisher sending data to the exchange, and in the queue here some consumers processing data. Fine. When you do these two commands, Rabbit will create this ghost queue there. It will create this link. And the bindings that you see there, it will be replicated here. So this queue up there will know what to send to the remote server. And the remote server originally had like one publisher, two queues, and suddenly started getting messages from a remote machine. What this happens is that we don't need to do anything. We just enable the plugin, and then we have the replication for free. To configure the federation, we can set parameters that are JSON objects, like this one, for example. And you can set, for example, to prevent unbound buffers, you can tell expires. If I cannot replicate messages after n milliseconds, then you can delete that queue, for example. Or if the message is older than n milliseconds, don't send it to the remote machine. You can set max hops. You can tell Rabbit how many servers the message can keep replicating to. You can have the ACK mode to do speed versus no message loss. On confirm, when the remote machine tells me I brought this message to the hard drive, the local or the remote server will delete the message. On publish, as soon as I put the message on the hard drive, on the network, it will be deleted. And no ACK mode is the living la vida loca or the alta replication version, let's say. And yeah, it's the fastest one, but you could lose messages. That's a URI you can use and the docs how to set it up. You can configure it on the command line, or you can do it using an HTTP API that Rabbit has to administer the whole server, or on the management interface that is like a web browser interface. And with federation, we can just do that. We can do this replication for free, let's say. Not part of the talk because there are only 50 more seconds. We have some blog posts about queuing theory and how to improve the performance of your Rabbit apps. I recommend that you go there. I recommend that you read this book, which has queuing theory applied to computer systems, which is really good if you want to improve the performance of your apps. It's a very, very good book. There are stuff about how to scale the setup that I'm not going to cover, mostly about how to do sharding with Rabbit, how to shard queues. And to end the slides, with Rabbit, what we can do is to get data in at least with 3 different protocols. You can mix them. You can publish using MQTT and then process using AMQP, for example. You can have this Internet of Things devices all sending data, but then using Java or Node, you can process everything using AMQP on the backend. With federation, we can do this distribution. Then you didn't see it, but with sharding, we can scale horizontally with queues. And then do some load balancing with federated queues that we also didn't cover today. Credits? Questions? No. Unless you have mate, of course. And thank you very much.
So I have some very good news. You won't have to listen to me a lot more, just a few more times. So that's very good news. So the next speaker I want to present is kind of awkward because I work in OutZero, and the next speaker also works in OutZero. So if I say he's awesome, you would say, yeah, but you work with him. So it doesn't sound so good. But what I'm going to say is that he's awesome anyway. So what he has done is he has worked in open source with Eich.js, and what Eich.js lets you is to run in Node.js code from C# or Python or any other language, and the same the other way around. Even though he's my coworker, I actually had to just talk to him to ask him how you pronounce his last name, because he's from Poland, and it's like really hard. And to be honest, while I'm talking at this, I'm talking more because I'm trying to remember how you pronounce it, because I've just forgotten. So I will improvise again. I love improvising. So everybody, you have to be a very good round of applause to Tomasz Janczuk, who is going to be talking about sandboxing in Node.js with CoreOS and Docker. Thank you.
Thank you. So my name is Tomasz Janczuk. I work for Auth0 with Gonto. And during this session, I'll be talking about sandboxing Node.js code in multi-tenant systems. So why would you even think about sandboxing Node.js code? Many multi-tenant systems enable extensibility by allowing users to write custom code that is then running as part of the platform. And since you know very little about what that code does and how it behaves, you cannot fully trust it. So that's why you need a sandbox to run it in. In Auth0, we are offering identity as a service. And as part of the authentication pipeline, we allow people to provide custom Node.js code that we are executing as part of every authentication transaction. People can basically customize the behavior, the authentication behavior for their applications and users that way. However, given that we don't have full control over what that code can do, we need a sandbox to run that code in. All custom code in Auth0 runs in the context of an HTTP request. So basically, the code must execute fully within the lifetime of a single HTTP request, which is the time span of a single authentication transaction. Given that, the sandbox model that we required also was based on HTTP. Basically, you were sending an HTTP post request to the sandbox. The body of the HTTP post request contains the Node.js code to execute. The sandbox runs that code, and when the result is available, it sends it back to the caller as a JSON object in the HTTP response. So this is a very basic sandbox model. The programming model around it that we have created is also very simple. You are basically writing a Node.js code that returns JavaScript function closure. That function accepts a single callback parameter. When you're done executing your code, you're supposed to return the result value to that callback. That result is then serialized into JSON and returned to the caller. What kind of properties did we require out of that sandbox? So first and foremost, we require data isolation. If we are executing code of one tenant, we expect that code to be unable to affect execution of code from other tenants in any way, or from accessing data of other tenants. So this is the kind of primary security requirement that we had. In addition to that, we also had a number of resource governance requirements around how memory, CPU, and networking is allocated. We wanted to prevent one tenant from executing an authenticated DOS attack against resources of our sandbox that would prevent other tenants from running code in the same time in that sandbox. So at a very high level, we basically looked at what is available out there in terms of sandboxing Node.js code, and none of the off-the-shelf components were meeting our requirements, so we decided to build our own. High level, our sandbox tenants is running every tenant's code in their own Docker container. In addition to that, we are creating an egress firewall around that Docker container such that the code running in that container can only talk to the public internet. It cannot talk to endpoints exposed by other Docker containers running on behalf of other tenants, or to endpoints exposed by our sandbox infrastructure, like the proxy, the controller, or etcd running on that box. So the way the system functions is that when that HTTP post request containing the code to execute arrives on the box, it is first landing at the proxy component. The proxy consults etcd, which is a distributed configuration system like Zookeeper, to see if a container associated with a particular tenant is already running. If it is, that request is then reverse proxied to that existing container. If the container doesn't exist, then the proxy will create a new one associated with that tenant, create a registration in etcd for future requests, and reverse proxy the request to that newly created component. In terms of preventing authenticated DOS attacks against memory, CPU, and other operating system resources, we are using a number of mechanisms. First and foremost, we are leveraging limits imposed at the C groups level. So C groups is a Linux mechanism.
Button, and someone's name will show up. We have a few rules. If your name comes up, you can't win something else. So if you win the mate, you don't win the drone. So that's rule number 1. But it's a beautiful mate. And we will give you organic yerba mate. The other rule is if you're not here, we can't give you anything. So if you hear your name or you see your name over stream, I'm sorry.
So even if you're wanting to pee, stay here.
Yep. And also you can cry. You can cry with joy when you win the drone. All right, so the first name is?
I can do it more.
It's taking a long time. It's not using JavaScript.
See, this is real random. That's why it's taking so much time, right?
Yeah, it's super random. All right.
Super.
It's SSL, it's so slow.
So we can see that Guillermo Rauch isn't perfect either. His software has bugs, so that's good for us.
We're preparing a second.
Symbolized here, so the inventor of Java. And we could just kind of like stick that on top of Gonk next to Gecko and basically just kind of wedge it into our phone. And then we could run messaging things on top of that. Of course, this is bad, at least for 2 reasons. First of all, Java has a really bad track record with security. They're still finding really fundamental bugs in Java, and they're often really bad because they affect all browsers at the same time. So if you do this, if you take a Java VM and kind of like stick it into our system, since the Java VM would be sitting directly on top of Linux and the OS core, we would basically create a second surface for vulnerabilities. There could be like additional bugs in the Java VM, and they would create additional room for the phone to be broken into. So that's a really bad idea to kind of put it in addition to the rendering engine. We basically have twice as much opportunity for something to go wrong. And then the second reason, of course, is that it would be really bad karma to put another Java VM into the web stack, right? So we got to the point where you don't want to need Java on a desktop. And with feature phones over the next couple of years going out of fashion, Java will also go out of fashion with it. So at this point, putting a Java VM into a web-based and standards-based and HTML5-based phone seemed like a really bad idea. So we decided not to go that route. So this, which was about 4 or 5 months ago, we already had a large number of phones out in the field that all don't have the original version of some of these messaging apps. If we do it this way, since we're not using any privileged HTML5 capabilities, we're not kind of trying to bypass the platform in any way, we can actually make an app, an HTML5 web app like this, and just put it in a marketplace where people can download it and they can use this without having to buy a new phone. So this is very nice because we address the existing set of phones as well. All right, the downside of it, of course, is now we have to write a Java VM in JavaScript. That's very exciting. As I said, my background is in writing compilers. That's what I did in academia before Brendan kind of freed me from academia, let's put it this way. And my entire background actually was in Java compilers before I started to do JavaScript compilers. So this is one of the reasons that I found this project particularly interesting, because I have done both extensively. I have written several Java VMs, and I have written several implementations of JavaScript compilers. I never really tried to write a Java VM on top of JavaScript. So that seemed very appealing to me. So for the next couple of slides, I will dive a little bit into technical details and explain to you at a high level how Java works and show you some of the problems that I ran into trying to build a Java VM that's really ready to run production-level code on a device like this. Don't worry too much if you don't see or understand some of the details. For example, there will be no quiz after my talk on the details of this slide. This is merely meant to kind of highlight some of the concepts you need to understand so you can understand the next slides. So on this slide here, really the only thing you should memorize is that Java is built from class files. Every Java program that you get consists of a large number of class files. And each class file represents one class. And these things are stored in a binary format. It's basically an array of bytes that contains information about the class itself. It contains the fields and the methods of the class, the actual code, which is stored as a bytecode. The bytecode you can think of as a sequence of bytes that explains what instruction the VM should take. And the VM goes step by step through these bytecode instructions. So really, all you have to do to run a Java program is you have to find a way how you can parse these class files, and then you write an interpreter for this language, this Java bytecode language, and then you run that interpreter over the code that you find in these classes. And once you have one class, that's your starting class, it will call methods. It can call methods in the same class, or it can call to other classes. And whenever it calls to another class, you have to go and find the class file for that other class. So that's the entire magic behind Java. Now, as I said, the Java programs consist of a large number of these class files. A popular messaging app like WhatsApp or Viber is often hundreds of different classes. In addition to that, you also have library classes, which are often thousands of classes. It would be, of course, kind of awkward to have to carry around 1,000 files if you're installing a Java program. So what they came up with is jar files. A jar file is a Java-like name for a zip file. So it turns out jar files really are like zip files. They're exactly structured the same, and they're basically just a zip archive with all the Java class files inside of that. And if you want to distribute a Java app, all you do is you give someone a jar file, and then the VM can go and read all that stuff out of the jar file. The first problem we ran into is that, as I explained, what we want to do is we want to write an app that knows how to run a Java program, and it will get that actual Java program from whoever is distributing the Java program, not from us. So the first step we have to make sure of is that this Java VM that we are writing can read these original jar files. So we need to be able to parse zip files. Fortunately, that's something I had to do before. So we did PDF.js a couple years ago to display PDF documents with HTML5. And there as well, the first problem we had to solve is that PDF documents are basically zip files as well. So you can see a meme here, like everything out there is a zip file, basically. And we had actually implemented for PDF.js a zip file reader that's up on GitHub. And I had that lying around there for like the last 2 years, and we didn't touch it since then. So I took zipfile.js, and I wrote a little parser for class files to kind of see how this goes. And it should work great, right? We can parse class files now, we can read zip files, and it totally didn't work at all. That was somewhat unexpected. So I spent a good afternoon trying to find out why the class files I was getting out of the jar files did not make any sense. And it turns out that if you read the specification of zip files, which I did, it's just a very painful process. I hope you never have to do that. It sucks. The specification says that any zeros at the end of a stream you don't have to store. So if you're storing a compressed file and the last couple of things in the file are zeros, you can leave out those zeros. The program that parses the zip file is supposed to know that if there's something missing, just add a 0. And I somehow didn't read this right the first time we wrote this implementation. So what the code originally did is if you're running out of bytes in your typed array and you get an undefined back, you raise an exception. So this is the error we were running into. And the fix, of course, is very easy. We simply read data from a byte array, and then we just or a 0 in there. This is a trick we will use a little bit later on a slide as well. What this basically does, it forces that to be an integer number, and undefined is the equivalent of the integer number 0. So whenever we read past the end of this byte stream, then we will start reading back zeros, which is exactly what the specification calls for. The neat part is that we shipped this bug in PDF.js for years. So people have looked at like billions of PDF documents, and nobody notices that this was wrong. This must be because the implementation of jar files and of PDF readers is separate. So the PDF readers or generators don't seem to generate this kind of optimization with 0 at the end. So since then, we actually fixed that in Firefox as well. All right, next step. So I had now a way to read jar files after some pain, and I had a way to parse class files. The next step, of course, is a VM. We have to go and get something that will interpret that bytecode and run the actual Java program for us. The most natural way of doing that these days would be, of course, to take mscripten. Mscripten is this C++ or C++ compiler that takes existing C++ code and it emits through LLVM and a couple other steps JavaScript from that. Over the last year, actually, we also did an extension of that called asm.js, which I think Brendan will show in his talk in a little bit, that makes it possible to make this really efficient. So if you do this path, if you go from C++ down to JavaScript, you can get really, really close to native performance. So if this worked, this would be great, because all I have to do is take KVM, which is written in C, and I could compile that, and I would have a VM in my browser or in my rendering engine. In theory, that's really great, and you should always reuse code if you can. However, in this case, I couldn't find a license for KVM. And I'm serious, there's no license. They put out code there, they're saying that there's no license, and they don't have a license for it. So I started calling up some old friends from Sun, and there's really no license out there. So for some reason it's out there, there's no license right now to use it, and I couldn't find anyone left at Oracle who knows how we could slap an open source license onto it. So I ended up basically not being able to use KVM because it's not allowed. You can only use it for research purposes. You cannot use it for any other purpose. So this was very sad because there's essentially no other open source project that implements this specific flavor of the VM. There's a couple open source VMs that implement the more heavyweight, complete Java VMs, but nothing implements this limited configuration that KVM needs. So one of the reasons I'm here today with you is because Sun didn't put a license on KVM 14 years ago. All right. So to write a VM, I went on GitHub and tried to find who else tried to do this. And it turns out a whole bunch of people have tried to write Java VMs in JavaScript. And everyone tends to do that for about 2 months before they give up. So I looked at all the different implementations that were completely incomplete. And the one I liked the best is called Node.jvm. I liked it because the code structure was maybe very nice and neat, or maybe just because his style matched my random style very well. But anyway, this was the one that I started with. It had a class file parser and a bunch of different other pieces that I was able to reuse. So with this, actually, I was able to get the first Hello World program to work. I very quickly realized that the way that they implemented natives is a really bad idea. So what is a native in Java? As you probably know, Java is a type-safe language. So there's a lot of things you cannot do in Java. You cannot poke around with memory addresses. You cannot directly call a system call that would invoke some service from the operating system. To do these things, Java has to somehow call into C code. And this C code is what Java calls native code. It's basically in the VM a way to recognize that you're calling a special magic method with a specific name, and that name is mapped to running a C function instead of trying to run actual JavaScript bytecode program. The way that the author of this VM implemented all the Java libraries is that he basically made every single Java library method a native method. So he would go ahead in JavaScript and implement every single thing that you need in Java in JavaScript. That, again, is a bad idea for a couple different reasons. First of all, there's a lot of stuff. The Java library that you need for these phones is actually not very large. It's about 1 megabyte as a compressed jar file. If you uncompress that, and because class files are actually very compact, there's actually a ton of code. It's a couple thousand classes, and those classes have a lot of different implementation details. My life is too short to write all of that again in JavaScript 14 years later. And again, also kind of felt bad karma to redo all this work that was done 14 years ago. So of course, a much better idea would be, even though we cannot use the same VM that Sun did 14 years ago, we could at least use the same libraries, maybe. And this is where we got lucky. And I'll come back to it in a second. The second piece, the second reason it's a really bad idea to try to write a Java library in JavaScript is that even though the name is very similar, and I'm sure Brendan has a couple more jokes on this one too, the name is very similar, but semantically these languages are very, very different. So in Java, for example, if you invoke a method and give it an object that is null, something very specific happens in Java, and you're supposed to raise a Java exception. So what the VM has to do basically is not just throw an underlying JavaScript exception, but the VM has to throw a Java exception, has to take a different path running bytecode, and it has to give the program a chance to react properly to that null exception. And because Java is so old and has gone through so many rewrites and so much code was written for it, Java applications tend to often really rely on these very subtle little details. So when you're starting WhatsApp, for example, it does rely on the proper handling of a null object dereference. If you start VChat like this, it relies on an integer division by 0 being thrown as an exception and being reported. So it would be very difficult to rewrite all this JavaScript code, all this Java code in JavaScript, and make sure that every single step you maintain precisely the semantics of Java. It would be, of course, much better if you can simply take the library code as Java, and then we simply run that in a VM. Then we don't have to write the code, and we have guaranteed the right semantics. So as I said, we got lucky here because Sun open sourced the library parts of Java, just not the KVM itself. So we could simply download from Sun's site the entire source code of the library that you need for these phones to work. That saved a ton of effort right there. That's great. All right, let's talk a little bit about the VM. So now we have basically all the basic pieces. We can read jar files, we can look at class files, we have the library stuff as bytecode. Now we need a VM that can actually run this code. The VM itself is really straightforward. As I said earlier, Java bytecode is just basically a sequence of bytes. There's instructions in there encoded. There's a little bit less than 255 instructions. They're numbered, and there's a definition that says if you see 0 in your byte stream, that's a no-op. Don't do anything. Just go to the next instruction. If you see 1, it pushes a null constant onto the Java stack, and so on. So the most trivial way of implementing this is simply you go ahead and you write a little interpreter. It grabs the current frame, and it pulls out the stack, and then it does operations on it in an infinitely spinning while loop. It's interesting to look at two parts of this loop, or this instruction execution. The one I'd already showed briefly a couple of slides earlier. In Java, you have strict typing. So in Java, you actually have different bytecode instructions for adding to integers or adding to long integers. Integers are defined as 32-bit integers, and longs are defined as 64-bit integers. So for integer addition, what you have to make sure is that when you add two numbers, they're always guaranteed to come out as an integer again. Now, we could make sure that the number that goes into stack pop on those two, they're always integers. However, if you add two integers in JavaScript and it's larger than a 32-bit integer, what you get is it just overflows into doubles. So JavaScript doesn't have this weird case of Java where if you go over the definition range of an integer, you kind of come back out on the other side of the world. Where, like, if you add 1 to the largest 32-bit integer, then you get a negative number. So that's really nice for JavaScript, but in case of Java VM, we have to actually emulate the way Java reacts here. Otherwise, if some program relies on this, it wouldn't work anymore. We use the same trick here. If you OR a number with 0, you force it to be converted to an integer number. And that way, we can implement the integer semantics of JavaScript. The second one is a long addition down there, and that's actually a little bit harder because JavaScript cannot directly calculate 64-bit numbers. You have only doubles, and a part of the doubles is reserved for essentially telling the system where the period goes. So as a result of that, we are using glong.js, which is the 64-bit math library that ships with a closure compiler. So all longs that are generated on the stack are basically wrapped into those objects that allow you to do 64-bit computation. Fortunately, on these feature phones, 64-bit math is very rare. So it's important to support it, but it's not really a performance problem. A more interesting instruction is getField. And for those of you who don't like reading code, I promise there's only 2 or 3 slides left before we go back to memes and things to laugh about. I wanted to show a couple more examples of stuff that was really interesting to implement. And as I said, I've written several Java VMs at this point, and implementing some of the more complex features of Java this time around in JavaScript turned out to be very, very different from any other implementation that I've done. A good example of it is getField. What getField does, it gets the value of a field of a Java object. Basically what it does is it resolves the field into a slot into the object and then tries to read from that slot in the object. The Java specification defines certain error conditions that can happen. One example is if you give getField a null object, then it is the reason we are doing this is that Java is a fully synchronous language. This is very different from JavaScript, where really one of the prime directives of JavaScript is try to run as little code as possible in your event loop and don't hog the event loop. Run small snippets of code and allow the system to run events as well. The way we implement this discrepancy is that we have an outer loop that you can see here in context prototype execute. And it's basically a loop where if the code that we run in VM execute throws this specific exception of VM pause or VM yield, what this code does is basically it jumps up and goes back to the event handler, returns to the event loop, and then next time we come around, we will run code again. So this is essentially how we implement the ability to take a Java thread, and at any time we can deschedule it so the system can do something else. And of course, this is also how we implement multitasking. Java is a multi-threaded system. All we have to do is basically have several of these things posted, and then you essentially have several threads that are running at the same time. All right. I promised that you will look at raise exception, and don't worry, most of this is not interesting. The only piece that is really interesting is the very bottom of this. If you look at the integer array, the uint8 array that we are generating there, what you're actually seeing there is that we're hand assembling some bytecode inside that method. Throwing an exception is if I have a second method in between there. So what, for example, can happen is, let's say you are trying to throw a specific exception with a name X, and that name doesn't exist. Then in that case, the VM would throw an exception telling you that a class could not be found. And when you're throwing that exception, you might run out of memory, in which case the VM is going to throw an out-of-memory exception. So you have to have this cascading. We are solving this with these synthetic methods that we are throwing in between the stack. This is very neat because the simple structure of JavaScript allows us to do this very efficiently, because we're using these uint8 arrays to actually store the stack frames. I mentioned a couple of minutes ago the concept of natives. Natives are in Java a way to call to the operating system or the underlying code. In JavaScript, of course, there's no notion of that. We simply call in the DOM or into functions that are implemented in a JavaScript library. So really for this VM, native methods are essentially implementations of code in JavaScript instead of C or C++, of course. There's a fairly simple way to implement this. What we essentially do is when you're calling a method, you supply the name in the bytecode. And we have a little override list where we look into, do we have a native with this name? And if so, we execute that JavaScript code instead of trying to call a Java method in the interpreter. So you can see a couple implementations here where we essentially just call some native JavaScript written code that implements those Java functions. All right. Almost done. One thing we did not expect is that just how slow this would be. So if you get onto this point, we were about 100 times slower than the application running on the feature phone. And that was really unexpected. Because most of the time, if you look at Java, it really runs a lot of the complex operations in native code. The reason for this is that back when Java was first written, there were no compilers yet for Java. So a lot of the Java programs could not do a lot of heavy computation in Java itself. So the Java language started to provide a lot of native C implementations of very complex functionality to compensate for the fact that Java was so slow. So we really expected that even if you have a slow VM for Java, we should be a little bit closer to usable than 100x away. It turns out that the main reason for this being this slow is that there's some very frequently called things in any programming language. Let's say comparing two strings. This is called in Java equals. In Java, all these things are implemented in Java itself. So if you're comparing two strings, you have to call this function here. And don't worry, I will not try to read through this, what this does. All you have to remember is that there's like 80 bytes or so of instructions in here, and I highlighted with red a loop that's inside of this. So what this code does, it does a whole bunch of checking whether it's really a string, and then it goes to that loop, and for every single character, it individually compares whether it matches the other string or not, and then returns true or false. And of course, each of these steps in this program, or Java VM, written JavaScript, has to interpret. So comparing two strings in this Java VM we just wrote is horribly slow. We did a little profile using the dev tools, and we could immediately see that most of the time was spent in 5 or 6 functions like this. So a very easy way to fix that, of course, is to use the same mechanism we just saw with native methods. A native method, again, is something that we implement in JavaScript instead of in Java. So we can simply take shortcuts. So I have a little native method that overrides the pure Java implementation, and it goes ahead and simply checks if that's a string, and if so, it does a string compare at a JavaScript level. That's, of course, massively faster because the JavaScript VM in the browser knows how to do that very efficiently. You don't have to like circle that interpreter loop all the time. So after the this work, of course, we expected things to get a lot better. And they get a lot better. It got like 10 times faster or so, but it was still kind of painfully slow to use. And the reason for that probably is that actually Java has advanced quite a bit since its early days. And today, most of the time when you run Java programs, you actually also compile them over to x86 or ARM machine code. So even on these simple feature phones, there's actually a compiler built in that takes the bytecode, and then instead of just running an interpreter, it generates machine code from the bytecode and then runs that machine code. And since we still had an interpreter, we were slower than these feature phone systems, to the point where the app was not really usable. So the next step, of course, is how to compile Java in JavaScript. And this seemed like a really daunting task for anyone who has written compilers. So for those of you who had the curse or privilege, whichever way you want to see it, to ever have written a compiler, generating code in a compiler is like the most painful part of compilers, because machine code is so hard to read and very hard to target. And it's also the most exciting thing to debug. Like you have not debugged in your life until you have trying to debug some machine code that goes wrong on you. And you're trying to understand what the hell happens there in some like binary machine code you're looking at. So when we got to this point, this seemed pretty scary, quite honestly, because every time I had done it before, it was a really daunting task to deal with. Fortunately, this is JavaScript, right? And it is not machine language, it's not x86, and it's not ARM. And it's a lot easier to do this in JavaScript, and this was almost unexpected for us. If you look at the compiler that is in j2me.js, that is probably the smallest Java compiler I've ever seen. And if you think about it for a moment, what it does, it takes the Java code and, of course, emits JavaScript code from it. It all of a sudden, of course, makes a lot of sense that it's a very small compiler, because what we're doing is almost like an inversion. JavaScript is actually a much more semantically rich language than Java, and has much more powerful primitives. What we're doing is we're basically taking Java and we are lowering it to this much higher representation. This is, of course, very easy, because many things where you have to painfully assemble in machine code instructions for Java are very, very trivial to do in JavaScript. We also harnessed a couple other tricks. To make this process particularly easy when you're trying to compile Java over to JavaScript, we try to use as much of the JavaScript semantics itself. So for example, Java objects are represented through one JavaScript object. We are not trying to implement our own garbage collector. We are not trying to implement many other pieces of the Java VM that traditionally you have to implement in some native language. So by making our Java implementation match very, very closely what the JavaScript language does, the actual compilation approach itself becomes really trivial. So this is what compilation looks like, and this will look eerie familiar to you if you remember the execute loop. It essentially does the same thing that the execute function did. There's a compile function, you go over the bytecode in sequence, and for every bytecode operation, you simply emit some code. And code in this case is simply a string that we define up there, and we concatenate into that string operations in JavaScript that basically emulate the stack nature of Java and execute the operations that Java is executing. So this turned out to be really a very easy way to compile code. This part was really easy, but what's a lot less easy is actually trying to run that code. We are running this stuff in an environment where content security policies are enforced. And if you don't know what it is, I recommend you go and read right after this talk, because it's very important that you know what it is. For those of you who don't know yet, CSP is a way how you can restrict web applications from doing dangerous things. And eval is one of those things that's pretty dangerous, because if you have stuff coming in from the user and it somehow gets into eval, that's usually where things go wrong and someone is going to take over your code and inject some code. So we are in an environment where we can actually not use eval. So we can compile a Java program just fine to JavaScript, but then we cannot actually eval it because the eval function itself is disallowed. I unfortunately don't have time to go all the evil details that it takes to bypass that, but essentially what we are doing is we are firing up a new iframe, and we load the code in that new iframe. And that iframe kind of posts messages us back and forth as we execute code. And it actually even works. So this was even surprising to me. One of the other authors, Mick, on this project came up with this idea, and it's pretty insane. If you really would like to see some fun code, I recommend you take a look at that. All right, now we're at the demo part of this. It seems that the convention is when Mozilla comes to demo, or at least when a Mozilla CTO comes to demo something at a JSConf conference, you have to show some sort of live demo. And Brandon already set a precedent that it is a game that you're playing. There is no Quake for J2ME as far as I know. So I picked the second closest thing I could find. And this is a live demo, so if it doesn't work, I'm very sorry. Let's see, where are my bookmarks? There we go. So this is the Asteroids Java game that is common on these phones. And great, the resolution is screwing me here. I cannot get to my start button. Let's see, that's great. It's live debugging here. All right, now it works. All right, so I can go to menu here. So this is all the Java stuff that's running. This is the interpreter loop running here, running this Asteroid game. This is a jar file. This is actually an open source J2ME game you can find on the web. It's on GPL. It's really great if you have to debug a VM, if you have a program you have the source code for. Try to debug with something where you only have the bytecode for. That's really painful. So here, these are touch events from the browser that are sent over to the Java VM. And I can go ahead here and start this. Everything you see here, like this very ugly yellow UI, this is all rendered in Java, in like 14-year-old Java code that runs on these phones. And I can start this, and then live demo, I cannot move my ship, so this is unfortunate. Let's see if you can do this if you start this again. No, I still cannot. All right, I cannot tell you why I cannot move my ship right now. It worked in a room there. You can believe me or not. But in theory, I would give you a live demo right now. Next time, I'm definitely going to record this and not show this live. All right, let's go back to our slides. All right, before I run out of time, first of all, thank you very much for listening to me going on about Java and JavaScript and VMs written in JavaScript. I would like to acknowledge a couple people that have worked on this project. As with many of the other projects that I started in the past, it's usually me who gets to do the first fun couple of weeks. And a bunch of people have to come in who have to do months of hard work to actually make it work. So there's a whole bunch of people from Mozilla and also outside contributors to help the J2ME get it to the point where it can run Java applications. And I recommend you look up their names. And if you're interested in the code for this, it's all up on GitHub. And check it out and run some J2ME stuff in your browser. Thank you very much.
All right, last talk of the day. Before I get started, remember that you can tweet with #JSConf.ar. If you have any questions, I'm sure that blew your mind and you're going to have a lot of questions. So obviously, Mr. Brendan Eich has no introduction needed, but I want to clarify and I want to thank him because what he did to get to Argentina today is really extraordinary. I want to thank Mejorándola because they took care of everything to make sure that he's here today. He's flying in and out of the country in the same day just to be with us today. So please, let's welcome him with a huge round of applause. It's not him.
Let's see. Did it work? Oh, let's hope. Wow, that looks terrible. Is that the right resolution? Is it good? It's such a big screen. Can we do better? Should I try? Dare I try? Yeah. No, I'm okay. All right, I'm not going to mess with this because I've had this thing crash on me. I'm going to talk about the future of JavaScript. I'm always talking about the future. As Santayana said, if you don't study history, you're condemned to repeat it. I think that's true if you do study history, too. So the future of JavaScript is Java. Because that's also the past. I'm only slightly kidding. I have to go back to 1995, which was when I was small, and JavaScript was created in a mad, tearing hurry. And I was thinking about this not only because of Andreas's talk about J2ME.js, but also because, I don't know, I missed the 90s. Vox.com had this picture in their piece about how that was the last great television season, 94, 95. There's like My So-Called Life and Party of Five and Friends. That's when I got my big break. This is me before my hair went gray. JavaScript had something to do with that. I'd go to, back then you couldn't find things on the web like you can now. Now I think you can find a lot of computer science papers, not all of them. Some of them are still locked up behind paywalls. But back then you had to go to a real library and actually read bound journals. And that's what I did. I would go to this place. This is Margaret Jacks Hall, at least the front corner of it, in Stanford University in California. And I would go read papers among the stacks. I also, maybe I went there because I read that John Doerr said, he's a famous venture capitalist, that any idiot could make a lot of money just by hanging around Margaret Jacks Hall. That's the computer science offices. That's where the computer science professors have their offices and office hours. That's where the computer science library is. That's the library that I was going to. I didn't become a successful venture capitalist, unfortunately. But I did read a paper or two, including one about Java bytecode. And this was right before I did the 10 days of work to create the first JavaScript engine. I was still thinking about Java, even though the Java VM that a friend of mine, Kip Hickman at Netscape, had started building had been killed. Netscape was doing a deal with Sun, and Bill Joy at Sun said, we can't have two Java VMs because they wouldn't have bug-for-bug compatibility. Netscape has to use Sun's source code to actually make there be only one implementation of Java, otherwise it'll fail. Now he was right. I think Bill Joy was right. If we tried to reverse engineer or even got source code access and built our own JVM, we would have had lots of bugs getting them to interoperate. And indeed, when JavaScript came out and Microsoft reverse engineered it, there were a lot of bugs in both engines, and we had to write a standard overloaded for multiple types, and you have to do crazy analysis to verify the code and do definite assignment analysis and do other things to make sure it's safe. JavaScript was all untyped, so I couldn't use the insight in this paper about modeling the types as you read the code, modeling the stack machine that Java uses in an abstract way, doing abstract interpretation. But I did use that idea for the decompiler that I put in. You know when you make a function turn into a string? In JavaScript engines, ever since I wrote the first one that I'm familiar with, some of them actually go find the source or save the source and give you that source back as the two-string result. The ones I've built up until somebody at Mozilla ripped it out the other year used a decompiler. So they would actually take an internal form like a bytecode and turn it back into a string. And I used the idea from this paper to build that. And I also thought at the time, why do we need typed bytecode? Java already has types in its class files. It has descriptions of all the types of the static and instance fields. It has type signatures for all the methods. Why do we need to have types on the bytecodes too? Here's another thing from the paper. It shows class vector. This is just like old Java. And then it shows the metadata, CLI data. So you could always figure the types out from the fields and the static members and all the signatures on the methods. You didn't need to have the intermediate instructions carry types and proliferate. But there were other problems that CLR bytecode did not fix, or the intermediate code for .NET did not fix. Meanwhile, JavaScript was there, kind of slow in the 90s, but still going somewhere, and finally taking off in the last 11 years, I'd say. So now it's 2014. A lot of water under the bridge. Java's pretty much dead on the client. Plugins, like Andreas said, are a malware vector, especially, turns out, the Java plugin. I think Brian Krebs, security analyst, said that it was the #1, in its day, it's probably not anymore, #1 vector for malware that people would pay for black hat malware that's bought and sold. ASM.js is a thing. It's a subset of JavaScript. It's like carving nature at the joints, like Plato said. It's finding inside JavaScript, thanks to the bitwise and shift operators that I put in that were in Java and C, and I put them in because they were in C. It's finding the subset that is typed in a way that can be very efficiently compiled to the machine, to the metal. And ES6 is all but done. Jaydson's talk this morning had a nice chart summarizing it, but here's the more hard-to-read chart. And if you look at who's winning, it's usually, it's IE now. The technical preview for IE now has the most of ES6 implemented. Good for Microsoft. Followed by Echo.js by somebody I knew at Netscape, Chris Toshak. Followed by Tracer, Eric Arvidsson's compiler that compiles ES60 to JavaScript, ES5. And then Firefox 35 is second after the browser in the front, which is IE. Ouch. So ES6 is kind of the last of the bigs. It was so big and so connected, we didn't want to cut it up into pieces. But after ES6, we're going to do smaller annual releases. I'll talk about this in a few minutes. ES6 did absorb typed arrays. So there's that word typed again. Now these aren't like Java typed, like you have to write down the types, but these are int 32 array and float 32 array. These are very important for working with the GPU and with SIMD units, which are also coming up. And then typed objects in ES7 kind of take away the wackiness, the fixed length nature in particular of typed arrays, and allow you to have descriptions, runtime descriptions of all your types of your properties if you want to. So typed objects will allow you to imperatively, through an API, not declaratively, say what the types of properties in an object are, and they can be packed together, they can be flat, they can be extremely efficient. It's kind of a generalization of typed arrays. So then we also have TypeScript and something that it inspired, according to the Facebook guys, Flow. And Flow looks very, very good because they've done a sophisticated analysis, or set of analyses really, that allow them to capture a lot of the idiomatic JavaScript without just giving up and saying, I can't type this, I'm going to just make it to type any. Everyone's really keen on seeing where these things go. But back to the class example from Java, I've rewritten it in ES6 using typed arrays, using a little bit of ASM.js typecasting. Like Andreas said, if you see that vertical bar 0, that's bitwise or 0, that is a cast to int32. And you probably know the other idioms for doing this. There's triple right shift 0 is cast to uint32, and twiddle twiddle x is a conversion to int. And you can do other things pretty efficiently. You can use plus as a unary operator to make arbitrary value become a double. So ASM.js relies on these typecasts. This isn't exactly pretty, but this will generate in a modern engine that can handle the syntax, like maybe the IE preview one. This will generate as good code as any Java VM would on that old Gosling code. So I say JS VMs are basically taking the dynamic untyped route to the same promised land that Java was promising, which didn't get delivered in the browser by Java. It got delivered by JavaScript. We're almost there. With typed objects and typed arrays, I think we'll be there. As Darth said, the circle is now complete. I guess this makes JavaScript Darth Vader, and James Gosling is Obi-Wan. Anyway, let me talk about standardization, because there's always angst about how long it takes to do a standard, and ES6 is big. I was involved in ES4, which helped get the standards body back in shape through the Harmony peace process that I brokered. But, thank you, standardization is going to go faster now. That's Ian Hickson's signature line. I don't know if it's original to him. Things that are impossible just take longer. We're not going to take years and years anymore. We're doing better. Here's how it looked, though, in 2011. When I spoke at TXJS, I took a picture of the TC39 meeting right before then, and it looked like that. And then there's also some famous artist in Italy did a picture of Croc and me. Croc's Plato, and I'm Aristotle. And I'm like, cool it, quit pointing up. I actually miss Croc. He doesn't come to TC39 anymore, and I looked around at the last meeting and I didn't see him, and I actually felt sad, even though he gets pretty grumpy. But we need the grumpy idealists. We need the Plato. Well, where would Aristotle be without Plato? So now, even without Croc, it's kind of a loss, we have TC39 doing its work on GitHub. My image is too big. You can actually see almost everything that's happening there. I think all the tests are moving there. I believe the specification is going to move there. It still has to be done in Word, if you can believe it, because of the way ECMA and ISO work. But modulo the Word issue, it's also in HTML as a first-class source for the specification. And people can send pull requests. The meeting notes are kept on GitHub and also available on esdiscuss.org. They're captured originally on, I think it's Alex Sexton's OK So Clap, Etherpad, or somebody's. Anyway, ECMA TC39 is no longer working in smoke-filled rooms or arguing in robes in the Greek marketplace of ideas. We're actually working on GitHub, which is good news. And for ES7 and beyond, we're going to work on an annual cadence where it's like the Chrome and Firefox release process. If proposals don't make it through a multi-stage waterfall, they just don't ship that year. They have to take a later train. So the trains always ship on time. So ES7 should be implemented. Some pieces of it are actually implemented now. Should be implemented next year and finalized. There's always a little bit of dotting the I delay. Finalized in 2016, and as you know, ES6 is going to be finalized middle of next year. So standards are getting better. Now, Jaydson did such a good job of covering ES6 that I thought I'd just talk about a few ES7 things that you might not have heard about. How many people here use promises in some library there? Good, okay. So you may know that generators, which I think Jaydson didn't cover, are in ES6, and I'll show them in a minute. But this example from Luke Hoban from Microsoft on the, he was on the ECMA committee until last year, shows if you were using promises to chain animations, say you had an array of animations, and you use this nice ES6 for let anim of animations loop to iterate over the values of the animations array. It's like for in, but it's over the values. Then for each animation, you'd have to chain using a promise and using p.then to call that animation, and it's kind of verbose. And then at the end, you'd have to worry about whether there was an exception, which you'd probably ignore. And you finally, with a final .then at the bottom, return the return value of the last promise, the fulfillment value of the last promise, which is what's being captured by this ret variable. Notice I've used let everywhere. There's no vars. So that's OK, but you can do better with generators. So in ES6, function star makes a generator, sort of like Python, inspired by Python, with some simplifications. And the task.js library from Dave Herman has a function called spawn. You pass a generator function star, to a spawn call, and you get a scheduler in the background that will resume that generator for you. And that generator can then yield each animation in turn. Notice that there are no promises here anymore. The promises are hidden inside the spawn machinery in the scheduler that task.js implements. So already this has gotten a lot simpler because it doesn't have promises with their Lambda callbacks. And it can use try-catch directly, whereas the previous slide had to use the promise.catch method and couldn't use try-catch. Notice also the arrow functions here, which make it nice and short. It wouldn't fit on my slide otherwise. But even with arrows, it's a little much. Whereas with task.js and spawn and generators, it gets shorter, and you can use real exception handling with try-catch. What we want to do for ES7 is go one step further, and this is, again, I think due to Luke Hoban originally at Microsoft, and I think this is in good consensus in the committee, and that's allow async to be used as a non-reserved conditional keyword, a contextual keyword in front of function, so that you can make this chain animation async function be an async function. And once you say it's an async function up there at the top, then inside it you can say await. And you see the await takes the place of the yield in the previous version. And there's no function star, and there's no spawn call. You don't need to use task.js. The scheduler gets absorbed into the ES7 version of the language. So async functions will not only depromisify a lot of your code, they will remove generators and task.js boilerplate and allow you to write something like this, which I think is pretty important, because JavaScript's going to be async in the browser forever, and it should be. Even if we have lots of new ways of composing workers, and we might end up making ways to make the non-foreground UI thread workers block, async's the way to go. So, and that's true in Node too. So I wanted to share that, and then quickly run through other things that are on board that you may know about. SIMD, I'll give a little demo, is single instruction, multiple data. It's architecture acronym that describes vector units, short units that, vectors that contain integers or floating point numbers packed, usually 4 32-bit floats or 4 32-bit ints, but they come in different sizes, 8 16-bit, 16 8-bit. Generally, they're multiplying to 128 bits. Intel's more recent work also has 256-bit long vectors. And they all get pieced up into power of 2 sizes for integers and floating points. Pretty important for speeding up DSP code, game code, physics code, graphics code. Typed objects I mentioned, value objects, which include, notably, finally, int64 and uint64 for real. And that means we don't want to just hard code these, so we're going to make user-defined operators and literals in the language so you can have your own operators. Probably makes sense for people using matrices and vectors. Even mutable objects could have operators, and you can go to town. And async generators, I showed you async functions. Async generators would be sort of what they sound like. That's something that's being worked on by Jafar Sen of Netflix. So ES7 is going to be smaller, you can tell. This isn't nearly as big as that giant Kangax chart. And maybe some stuff will get cut, but we'll get it done. It'll be spec next year, implemented next year, and finalized into the beginning of the following year. And that's exciting, but nothing beats excitement like a demo. So I'm going to try to show some things here. First of all, this is the demo from the Intel folks showing how SIMD can speed up your code. Here's a Mandelbrot generator. And if you don't have SIMD, it starts off a little under 30 frames a second, and it degrades because the complexity is growing as we zoom in. If I say use SIMD, it zooms up by almost a factor of 4. And it will again fluctuate depending on the complexity, but it's still roughly between 3 and 4 times faster because it's getting that 4-fold speed up for the parallelizable parts of the code by using 4 float 32s or 4 int 32s at a time. It's using vectors. So all the additions or all the multiplications happen at once. So game developers and people writing all sorts of things will benefit from this. Now, I don't want to make it sound like it's all about games, but it's important to give games their due because they stress test everything. I think I saw the CTO of Valve many years ago at Game Developer Conference say that only games were really pushing as applications, as a class of applications, only games were really pushing on concurrency, parallel hardware, vector units, SIMD, GPU programming, aggressive memory management. So games are like the really hard case. And this demo I'll start with is the Banana Bread game based on the open source Cube 2 engine, a C++ code base that's compiled to JavaScript by Mscripton. It's compiled to ASM.js. This version is fun because it embeds Doom, the free version. And so you can be in the outer game. I'm going to have to kill this bot before it kills me. There's a bot that's going to come out in a minute. And you can see this inner game is on the wall there. And if you, OK, remove bot. If you hit vertical bar, now I'm playing the inner game. To prove this isn't a video on YouTube, as somebody accused me of running, I'll let you guys tell me which game, first episode, second episode, third episode. You should clap. Third. All right. This one I'm going to use Please Don't Kill Me. I believe control shoots, yes. The arrow keys turn. So the outer game is like WASD to move around. And the inner game is arrow keys. I think I can strafe. Yeah, I can strafe with greater than and less than. And slash does something. I'm not sure what. And there are monsters in the inner game. This is like, oh yeah, do I have to like, how do I hit that? There. Now I'm in trouble. So I'm playing the inner game. Taco demon. All right. Come on, die. Ow. OK. Now what's really cool about this is there's a, where is it? Oh, it's in my off-screen banana bread. Thank you. Let's get out of this. There's just a few hundred lines of JavaScript to glue the inner game to the outer game using a worker. This is from Alon Zakai. You can see he sets up a worker that contains boon.js. Boon is the name of the free Doom code. And that's in a separate JS file, and it runs as the worker source. And then this is Unreal Engine 3, which is still a good demo. When I mentioned Java bytecode, here is the new Java bytecode. This is the actual, it's going to take a while. It's big. It's ASM.js, so it looks quite voluminous, but more fun to see the game. Let's go here. So this is, I hope it's going to make sound. I hear it. Does anybody else? I think it's only me. Somebody has to stick a mic here. Oh, good. And then I'll show you my mad skills. These are It's fully playable, smooth, 60 frames a second, and I'm cheating massively. I'm in God mode. It's good. You get really nice effects if you look at the God rays from the sun. See the ray tracing. This is all WebGL and ASM.js code, which is not so pretty, but there's your modern bytecode, right? There's your Java has a number of if greater than or if equal branching, conditional branching instructions. JavaScript has the if statement. Java has, integer operations. There's your or zero. That's your cast to integer. So I just wanted to show that. Okay, the last thing is not only the Epic Unreal Engine, but also the Unity engine has been cross-compiled with MScript and its runtimes ported to the web. So Unity is supporting HTML5 WebGL as a first-class target, ASM.js as a first-class target. This is Dead Trigger 2. It's pretty fun. The best part of this game is the sentry chickens. They have machine guns on their back. So they take care of those zombies for you, no problem. And again, smooth gameplay. Oh, he's trying to crawl after me. Ah, they got him. These kamikaze guys will try to blow you up. So the best thing to do with them is a grenade. I'm not in God mode here, but I'm doing okay. I can take some health just in case. Oh, there's that big kamikaze guy. Watch out. Uh-oh. Grenade. Second grenade. Oh, good. Okay. All right. So, like I said, games are fun and all and kind of violent, but they're also if you can dodge a wrench, you can dodge a ball test. So if you can run these games, you can run a lot of code. And that's why I always close these talks with this homage to Wesley Snipes in Passenger 57, another 90s movie. It was not that great. Wesley's always awesome when he gets his martial arts face on. But always been on JS. It was never going to win. It was this incredible underdog for too many years. And then when it started coming up, there was still Flash, there was Java plugin. Pretty much all JavaScript now. All the browser vendors are acting serious about it. We're evolving it. We're going on to a rapid release process. We're adding all the hardware APIs you need to do everything with the machine. And it's kicking Java's ass. So always bet on JS. Thank you very much. Hey.
So now we're going to do the Q&A with Andreas and Brendan. We have 5 questions selected from your tweets. So please take a seat here.
Cool. Thanks.
This is so exciting. I'm so close to him. I have a phablet loaded with questions. So the first one came from a tweet that I think is really, really interesting. So Brendan, at what point did you start imagining that JavaScript could one day run and control robots or games within games or zombies in WebGL compiled from C++?
I think around the time Friends went off the air, and I lost my gig there as Chandler. No, I didn't foresee all that. I thought it was going to be a glue language, or what some people call a duct tape language, which is really, I think, not a meaningful phrase. It was going to be the little brother or the sidekick to Java, and Java would do all the applets and components and beans, and those would be in your browser, and JavaScript would just be how you glued them together, sort of like Visual Basic was to C++ in Microsoft's Windows environment at the time. But Java never really got out of the applet cage. It never loaded quickly. It never learned about the DOM. So I think that was fatal.
Awesome. So basically, JavaScript was only going to be for embedding applets. Now it's for reinventing the JVM inside JavaScript. It's pretty awesome. So another thing that comes up a lot is JavaScript, to some people, has good parts and bad parts. And now with all the ECMAScript 6 and 7 innovations and additions, it creates new opportunities for now narrowing it down again. Do you foresee that people are going to be creating JavaScript's good parts again now that we get all these new features?
I think this is true of the web in general. Like HTML has bad parts. CSS, I think we all know, has bad parts. The funny thing is, people think when you have an evolving system that if a new requirement comes into the system, you have to evolve quickly. That's not how it works in nature. You already have to have had the genetic diversity and already have evolved to survive the new disease or the new predator. So the same with JavaScript and HTML and CSS. They're going to have too much in them. They're going to have mistakes. They're going to have things that you can't remove because they already are used by some pages or apps on the web. But they can be deprecated and they can fade away. And so I just tweeted back earlier before coming on stage. I don't agree with Crockford. He's too prescriptivist for my taste. He says, there are the bad parts you must never use, and there are these little good parts that I say you should use, like the closure pattern against the prototypal pattern. It's too extreme. And JavaScript needed to have more patterns or more strength to it in order to survive for unforeseen circumstances. It needs to keep evolving as it has. So I think there will continue to be messy evolution with bad parts, and we won't even know they're bad until later. That's the killer. I don't know if you want to add.
Yeah. Hello? I might add something.
Is it off?
He has no opinion. Can we?
Hello?
Yes.
Now it works. All right. Yeah, I think especially the part around removing things being difficult is very true. Brendan's explanation reminded me of a property I found in a DOM in Mozilla's implementation a couple of years ago. It's called navigator.enableTaint. And Brendan added that like 15 years ago, and it always returns false because he never actually implemented taint propagation. And I asked him, kind of yelling across the desk, like, what the hell is this thing, and what does it do, and why is it here? And in my moment of like attempted purity, I submitted a patch to remove that property because clearly, like, nobody would use this. It was added 14 years ago for a feature that never got implemented, right? And this went to ride the train in Firefox, and I broke like half the web because it turns out that jQuery uses that to detect whether you're running on Firefox or not. So. That's really great. Only at JSConf do you get applause for breaking like half the web. That's awesome. Thank you very much. I feel much better about it already. So yeah, removing this kind of stuff is very hard. It has to be very slow. We have removed stuff in the past successfully. And E4X, for example, was removed after some pain. So it is possible. It simply takes a lot of time.
I think there's a biologist who wants to breed chickens to express what are called genetic atavisms, chickens with teeth, like dinosaurs. Because that old enabled taint method is still down there in their DNA somewhere. Maybe they can get teeth. Maybe enabled taint will come back. I don't know.
Actually, I have a very hard question for Andreas, I think, because he talked so much today about JavaScript being a great target for compilation. So when should we use Rust, and when should we use JavaScript?
So Rust was designed for a very specific purpose, to rewrite system parts. And there's actually no necessary hard distinction between these two languages. I already talked to the team whether Rust should be able to target JavaScript. There might be some cases where it makes sense to use Rust to implement something that runs on top of the web stack in JavaScript. And there might be other cases where it makes sense to implement system parts as JavaScript. So I don't think there's a necessary order there. And I would be surprised if we don't have a Rust to JavaScript compiler at some point.
Yeah, I agree. The Rust's main sweet spot is safety with the same memory control that C++ gives you.
All right. And you mentioned types today. And in the community, we see a lot of different projects for tackling types in JavaScript. So we have AtScript now coming out, TypeScript, Flow, Dart, just kidding. So what do we do? Which one do we use? What do you think about these projects? Do you think, once again, that the better one will win and the rest will die out?
I think we're still in the early days. There's been some interest in ECMA TC39, the standards body, about standardizing something to do with types, maybe based on TypeScript and Flow, both using the colon annotation like the ML languages do, like Pascal, if you remember that does, Algol languages, some of them anyway. That syntax, var x colon t, you can't just standardize it. It has meaning. If you define it, it has something to say about the types system and the type expressions or type annotations. So we're not going to rush to standardize that. The only thing we're doing now is saying that no engine can go claim as an extension on its own that colon after the name in the declaration. That's reserved to the future standards that might standardize it. I think TypeScript and then Flow, inspired by a much more powerful, should keep going. I think the best thing they can do is get adoption. The worst thing that you could do is make design by committee, union of all the systems or intersection of all the systems or some committee Frankenstein standard. That would be terrible.
All right, and the final question for you, Brendan. Someone was wondering about what are the biggest lessons or takeaways from TC39 and in general the approach that has been taken towards improving JavaScript? And where do you see that going in the future?
It's been a long road. I think that my big takeaways in like 20-year terms are you need competition to drive the vendors to cooperate in the standards bodies. Then you need good social relations among the members of the committee. Even, Croc is welcome back anytime in my book. You need to get on this rapid release footing we're trying to get on with ES7. You don't want to do big, indefinite projects in software or in standardization because they always suffer scope creep and the world moves out from under them and they become irrelevant dinosaurs. So some kind of rapid release footing with implementers constantly implementing. W3C, really originally the WhatWG, tried to get browsers to do this with HTML5, and that became a big living document standard. But I think now things are getting across the web space onto a faster cycle, and that's one of the biggest lessons for me.
All right. All right. Thank you so much, guys.
Thanks. I like your fabric.
So now I'm going to get out of the way for a parting gift for all of us that it's basically going to be a surprise followed by a party. So stay tuned.
Hands out to the sky, we dance with monsters through the night. Whoa, oh, oh,
Come on, team. Venga, dale. Voy a invitar a todo el equipo de gente excelente que hizo que este evento fuera posible. Desde nuestros presentadores, sponsors, Paula. Si algún speaker, any of you talk to Paula, you know how amazing she is. Vamos. Vamos, dale vuelta. Bueno, y ahora nos vamos a dar vuelta para una foto. Foto grupal. Todos nos damos vuelta. Sale de arriba.
¿Dónde está la cámara?
La luz nos está matando. Ahora vamos todos organizadamente hacia la fiesta. A medida que van bajando les vamos a ir indicando por dónde es. It's walking distance from here. So let's all go to the party now.
Like this.
Ain't no happy